بسم الله الرحمن الرحيم والصلاة والسلام على نبينا محمد وآله وصحبه. Dear President of King Fahd University, Petroleum and Minerals, Dr. Muhammad Al-Saggaf, our distinguished speakers, my colleagues, students, ladies and gentlemen, I would like to welcome you to this forum titled Digital Transformation with IoT, Perspectives and Challenges. Let me first welcome Dr. Muhammad Al-Saggaf to give the opening remarks of this forum. Dr. Muhammad.
Okay, Bismillah ar-Rahman ar-Rahim. Dr. Ayman, our distinguished guests, those who have made it and those who are still trying to get in, I'd like to welcome you to this KICS event, the KFUPM Institute for Knowledge Exchange, organized today by the Department of Computer Engineering, Dr. Ayman Al-Malih and his group. I'd like to welcome everybody. This is the first such event organized by the Department of Computer Engineering. Our plan this year is to conduct numerous such events by every department and research center at the university, and at one point to switch to physical presence and to national audience, and to make this an important milestone in our desire to become a hub for the dissemination of knowledge worldwide, both within academia and between academia and the industry. And today's topic in particular is one that is of very much primary importance. If IoT is not the topic of this age, is definitely the topic of tomorrow. It's growing in importance very rapidly. It's touching, by definition, our lives in multiple ways. And can you please mute your phone? Mute your, yes, thank you very much. IoT touches us because we interface with it on a daily basis. In particular, I am one who is quite fond of the Internet of Things, of sensors and actuators and automation and home automation, and my own house is laden with a lot of lights that open and close according to who is there, power meters and sensors and so on. And I think it is a way of the future. And of course, we have it in our watches, and we have it in our smartphones. And the future is going to be more and more of the penetration of internet into our lives, with things like long-range networks, LoRaWAN, and personal wide area networks, and wireless personal area networks like Zigbee and so on. And the future of IoT in the industry, with industrial IoT and its penetration into industrial control systems and so on and so forth, including the security of IoT devices and edge computing, and performing many things at the edge rather than doing them centrally, and communication between these edge devices and so on. It's very, very smart, the future, and it is very, very exciting. I'd like to mention a few things about KFUPM in this brief, at least what I'll try to be a brief introduction. KFUPM wants to embrace the world. It wants to embrace companies, whether they are close to us like Saudi Aramco or far away. It wants to embrace industrial partners everywhere, international academia, government agencies, and so on and so forth. The university over the past couple of years has significantly overhauled all of its programs. It has overhauled all of its academic programs by basing them on a platform we called AI plus X, Artificial Intelligence plus X, whereby every undergraduate curriculum is based on artificial intelligence. We introduce numerous concentrations, among which are undergraduate subspecialties, including IoT and artificial intelligence and cybersecurity. And we introduce numerous Master of Engineering degrees, including high performance and edge computing and artificial intelligence and so on and so forth. And we overhauled all of our research programs along the way, introducing 20 new research centers, and the journey is ongoing. During the past 2 years, KFUPM was rewarded in terms of its global ranking. We moved from a rank of 200 to currently 163 worldwide. We are currently number 7 in the world in petroleum engineering, number 14 in minerals and mining, number 60 in chemical engineering, number 84 in electrical engineering, before many prestigious universities such as Wisconsin-Madison and Southern California and UC San Diego and Santa Cruz and so on and so forth. And number 98 in civil and structural and so on. And we are very proud of the roots of KFUPM, and we are very proud of the transformational journey that it has taken. And it is a journey that will take some time, but its fruit is very likely, in fact, I would say guaranteed, to make the university a much better partner for its stakeholders, a much better partner for the community, and one whose outcome in terms of academic and research activities transcends academic papers and publications into improving the human condition that amplifies impact on society, and this is truly our goal. I will not take a long time. I'd like to welcome you again. I thank all the participants for taking the time to join us. And this is just the beginning, as I said. This is a long journey, especially the journey with KICS that would hopefully see KFUPM indeed becoming a center of gravity of international forums and symposiums. Thank you very much to the organizers. Thank you very much for the participants. And thank you very much, our dear audience. Thank you.
Thank you, Dr. Muhammad, for this nice opening remarks. This forum has 2 sessions. The first session titled The Role of IoT in Digital Transformation, and we have 3 distinguished speakers. So we'll take the questions at the end. This will be moderated by Dr. Mohammed Al-Jallad. The second session is titled Challenges and Future Trends in IoT. We also have 3 more distinguished speakers. And this will be hosted by Dr. Nabil Alnuaim. So I'll give the floor now to Dr. Al-Jallad to introduce our first speaker in the first session.
Assalamu alaikum. Thank you, Dr. Ayman. Thank you, President Dr. Muhammad Al-Saggaf, for the opening remarks. So without further ado, I would like to start or kick off our first session, which is titled Role of IoT in Digital Transformation. We have 3 distinguished speakers in this session: Mr. Nabil Alnuaim from Saudi Aramco, Mr. Murhaf Almadani from SABIC, and Mr. Yasser AlSaied from Amazon. So before we start the session, just a few remarks. As Dr. Ayman mentioned, that we will give the floor to each speaker for about 30 minutes presentation, and then we'll be happy to collect your questions, and we will conduct the question and answers session during the panel discussion, with the exception of Mr. Nabil Alnuaim. We know that he thankfully agreed to join us, and he has other commitments, so we might right after his talk, we might take 1 or 2 questions. So our first speaker is Mr. Nabil Alnuaim. Mr. Nabil Alnuaim is the Vice President or the Chief Digital Officer in Saudi Aramco. He was appointed in 2018. Prior to January 2018, Mr. Alnuaim served as Head of Transaction Development, and he was actually responsible for executing joint ventures. He has over 26 years of experience in oil and gas and renewable energy industry, both in Saudi Arabia and abroad. Mr. Alnuaim has held managerial posts with Saudi Aramco's international operations, environmental protection, among many other positions. He also undertook duties as Director of Kingdom Economic and Energy Analysis and Director of the Kingdom Energy Strategy, and he was the Chief Energy Chief of Energy Research at CAPSAR. Mr. Al-Naim holds both a bachelor's degree and master's degree from King Fahd University in Electrical Engineering, as well as Texas A&M. He also obtained his MBA from MIT Sloan Business School. So without further ado, please join me to welcome Mr. Nabil Alnuaim. Mr. Nabil, the floor is yours.
Assalamu alaikum jami'an. Can you hear me, Muhammad?
Yes, I can hear you, loud and clear.
Okay, so thank you very much for the introduction.
I'll stop sharing if you want to share your screen.
Okay, I have Dr. Abdul Ghani with me. He will, I think, start the sharing. Even though I'm the head of digital, but maybe I'm not really good with the Zoom tool. So, Dr. Abdul Ghani, can you please share?
Okay.
First of all, I would like to thank you, Dr. Muhammad Al-Saggaf. Muhammad Al-Saggaf, he was my boss. I was really happy to see him turbocharging the new technology, specifically the digital transformation within KFUPM. Thank you very much, Dr. Muhammad, for allowing me to participate today with the distinguished guests and the speakers. I thought about what topic shall I talk about today. I can talk about the great journey that Saudi Aramco, being a leader in the energy and also among the top quartile when it comes to implementing digital transformation across the value chain. And instead really talking about Saudi Aramco journey, I thought to bring some challenges that we see that digital transformation probably can resolve in the oil and gas companies, that they have the code to implement what we call hyper automation in the digital transformation arena will be the top leaders moving forward. So I thought to bring to the academia, to the industry leaders, to some of our peers in the energy sector, some of the new trends that we'll be seeing, and we hope under the leadership of Dr. Muhammad Al-Saggaf, he takes this further. I've seen some of the interdisciplinary programs that KFUPM is really taking the lead here in the kingdom, and also regionally when it comes to linking different streams in order to transform and solve complex problems. And this really makes us in the industry extremely happy. And I will share with you a few of the items that I would like to bring to your attention. So when we talk about hyper automation, what do we really mean? Next slide, Dr. Ghani. So if we can you show the definition, Dr. Ghani, or this is something I will talk about. What is really hyper automation? We know that the oil and gas industry and auto industry, they've done a lot of automation. So what are the things that we are talking about here? Basically, we are talking about a business-driven approach for any industry, whether oil and gas or pharmaceutical or even manufacturers of pipes or other commodities, in order to rapidly automate many business processes that we have in the sector, while involving and integrating the use of multiple digital technologies and also platforms such as artificial intelligence, what they call in the industry, and Dr. Saggaf mentioned a few, like the RPA, robot process automation, some physical robots, smart sensors and IoTs, drones, cloud computing and the like. So and this is why it's called digital transformation. It's not only deploying like a technology track, it's really coming up with a business challenge and trying to resolve and maybe change the operating model, using several technologies. And this is the trick. And we've seen a lot of startups. We've seen also some academic programs that they teach you, for example, how to do programming. or how to build a goggle to support virtual reality, augmented reality, or how to new techniques for building KPIs, or wireless type of or new communication techniques and with new communication protocols, or smart sensors. I think transformation or the hyper-automation is going to address really big challenges. And these challenges will have to integrate different technologies. But once we define the business problem, once we know exactly what is really the end state in order to really solve this big challenge. And I'll just cite one example of, you've all heard about the net zero emission targets that all the companies almost are making announcements. If you take this in consideration, what could be the digital, I'll call it backbone, that will really support the collection of data, cleansing of the data, making sure that the data is certified, and then the data is also shared and transferred between the producers and the consumers. Because what is known to be a scope 1 for one industry, and scope 3 for the same industry, it will be scope 1 for the other industry. How do you make sure that the carbon footprint and the calculation of the emissions is captured and authenticated and traced, and there is no double dipping? If you think about it from a technology point of view, this is a very classical, what they call a use case or a project that will integrate blockchain, maybe RPAs in order to do a little bit of mechanical work, and then AI to do the authentication. And there could be, other technologies such as drones or low orbit satellites to capture the data and make sure you authenticate and you verify this data. So this is really what is a hyper automation. The IoT, or the industrial IoT, these are instruments that, typically we are, as an industry, we've been putting a lot of, in what they call level 0 and level 1 in the DCS systems, that you put a lot of instrumentation, but there is a big revolution in the IoT itself. So there are IoTs that they have on-edge computing. So you don't have to send the information to a central location. The device itself or the instrument, it can do the calculation, and it has even AI and intelligence in the edge. So therefore, how do you make sure that these edge devices, their algorithm gets updated frequently with the with all the learning that probably the headquarter or let's say control towers understand. So hyper automation is really the collection of really solving a major problem by implementing and deploying several technologies. So hyper automation, what are the things that needs to be considered when you think about hyper automation? And in every topic, there are challenges. So these devices or systems will have to be interconnected, and they have to be integrated. And we know how difficult it is to integrate different systems, and it takes sometimes years. But there are a lot of platforms that have this already embedded part of the DNA of these digital platforms. So imagine that you have a digital platform that has the capabilities or the APIs like adapters that connect to the ERP system like SAP, to probably Microsoft, to connect with other systems and with other system that does the monitoring of the emissions or process information. So they have to be integrated and also interconnected. So the interconnectivity and integration of these solutions is something extremely important. And we've seen it in Aramco, that we've done we disrupted some of the way we do business by really managing the interconnection properly, but it has to be led by the business, entity rather than a technology company. So because they know what is really need to happen. The other topic that, in my opinion, in addition to the challenges that typically you face to integrate and connect the different systems, is bionic operations. Basically, how the machines will deal with human beings. And there are a lot of touch points. Let's take a legged robot that you put for inspection. So what do you want this robot to do? It has to be trained by a human being. So how do you really create a relationship between the robots and the human beings? How do, what type of data the human beings, the subject matter expert, need to pass to these robots in order to do some of the repetitive work that typically human being is redoing. So we need to think about, some sort of a digital worker type of agreements. So this requires a lot of change, management of change. Some of the subject matter experts, they think that they will be replaced by robots. Robots is gonna not replace the human beings, but however, the human being will be doing much more added value, and decision making, compared to some of the clerical or simple or repetitive work that robots can really do. So the bionic operation will have to be considered, with the hyper automation. Multi-cloud, there are cases, and I'm sure a lot of industry leaders that they've seen different cloud service providers. They have different ecosystems. There is a big revolution in the way cloud is providing their offerings. You will find a specific solution that is under Google Cloud to provide a specific service. Could be AI or any other application. Microsoft, they have different ecosystems. So how do you deal in the future, under the hyper automation with different cloud service providers? You have your own data centers, you have your own private cloud, but there is a big revolution in the cloud that you can tap into. So you have to think about the regulations of the country, the sovereignty of the data, the governance of the data, but at the same time, think about how the cloud is going to give you a very quick access to computational power. Instead of waiting for servers to come and takes years, you just tap into, this hyper cloud and you access all the, it becomes like a commodity. If you want, for example, a mobility to be part of your system, it's already there. So how do you, tap into all the resources that is available in a multi-cloud? It's going to be a hybrid. And with hybrid cloud, you mean there is big complexity in the architecture of designing, the future, of your digital infrastructure. It has to be distributed, IoT. I talked about edge computing. That has to be probably on the future will be more and more in the IoT devices, whether industrial or non-industrial. There are talks as well of pushing the intelligence or the computational power, like you have on the edge cloud computing next to the facilities, in order for these IoT devices to do their functions, very quickly. There are a lot of different protocols. How do you communicate? Do you use industrial Wi-Fi or use 5G, or there could be 6G in the future? Is it wired, unwired? So there are a lot of IoTs that are distributed, not necessarily for oil and gas. Let's speak about autonomous vehicle, operation in our highways. So what type of IoTs are required? How do you communicate with those IoTs? This is something that the industry is working on. It's much more standardized in oil and gas industry compared to the other. So I think there's a big field as well for the academia, to work on in collaboration with the industry. Finally, AI. Everybody talks about AI and machine learning, how the machine learning, they become the mainstream of this is decision support and decision, making and the analytics. But machine cannot really operate without data. And how do you make sure that the data has the high level of quality? There are cases where, the industry works on almost a couple of years in order just to clean up the data before they start, operating their machines. Therefore, we identify, areas, and this is a big field for Aramco. One area that Aramco is also working on hopefully establishing is like an Aramco.ai, subsidiary company that will manage the data and push the envelope for using the data that Aramco has to provide service, especially in sustainability and ESG type of work. Next. Can you hear me? Dr. Abghani, can you go to the next slide? Okay. This is I don't want to be academic and just talk about, what is really hyper-automation. This is a very classical example for any industrial facility. This is just a demonstration, in case, let's say a leakage has been identified or a problem by a robot or by a drone, that's supposed to initiate notifications, supposed to automate all the actions required by the digital workers, by the control tower. If there are spare parts that, is really required, 3D printer will be probably does its job, initiation of work orders, integrate with the supply chain, checking whether, whether this piece of device is available. If it's not, then you initiate a work order to your suppliers. This is a very typical example. I thought just to share with you to demonstrate what are we talking about hyper-automation. This is what is going to bring disruption. And this cannot happen unless different technologies operate together, different disciplines also operate together. So the supply chain will work with the operation guys, with the maintenance, with the IT, with could be data scientists, in order to, bring a automation platform to automate, but in a very hyper scale type of solutions. There are opportunities, or there are systems in place that is, it will solve this problem, but it's not fully automated. It's, it's like a semi-automated. Every, like a drone, it will detect something and then it will go to someone and he has to take the action. How do you bring the digital platform, different technologies, different business processes, they get integrated? It's like orchestrating, a very comprehensive and very, in a very integrated and interconnected. Some data can be in the cloud, some data can be in data centers, different platforms that will have to talk to each other. Technologies are there, but how can you break the silos? How do you, put the right regulations? How do you train the employees? This is really the disruption that is going to come to all the industries with digital transformation, and it is accelerated by the pandemic. We've seen how the digital transformation became the, clear focus by countries and, by industries to solve major issues. Even in the, if you look at what has been done in terms of data, analyzing the histories in order to come up with the vaccine for COVID-19, digital transformation has a big part of it, to create the right models and the right, to accelerate even the testing. So I thought to share with you this just to demonstrate a challenge that I hope the academia, and especially the program, the great program that KFUPM really initiated in order to solve major complex problems in several industries under the leadership of Dr. Muhammad Al-Saggaf, will be considered, and we'll have more alliances and more like consortiums, collaboration between the industry and the academia in order to bring these solutions to become like a plug and play, rather than takes you years to integrate these different systems. So this is what I thought to share with you. And thank you very much for listening.
Thank you very much, Mr. Nabil, for the insightful talk. So I think I'll open the floor. Maybe if we can allow us to have 1 or 2 questions, I'll open the floor to our distinguished panelists here if they have any questions. Any questions? Okay. Meanwhile, I think you mentioned one. Okay, I think there are a couple of questions here. One question from Shakir Hashlan. With hyperconnectivity comes more risk of cybersecurity, and we know that standards and practices are usually behind the creativity of the attackers. So the question is, how do you control such risks on hyperconnectivity?
A very important question. You know, something I learned, you know, from all the digital solutions that we brought in, that, you know, part of the risk mitigation is you have to review the you know, all the loopholes and look at the architecture and identify all this early on. So you cannot just deploy it without going through the proper you know, proper checks. And we in Aramco, we have clear standards, even the cybersecurity standard within the kingdom, in terms of data retention, in terms of integration with external. There are, you know, very clear standards. I think the issue that really comes into place if we bring a new communication media into the facilities. So can the attackers, you know, attack if we get into a 5G, for example, connecting between devices, you know? And I can assure you, for every challenge there is a way to solve it. But this is something we cannot avoid, because if we in the oil and gas, and we are, by the way, in the oil and gas as an industry compared, let's say, the financial sector as an example, we are not as mature in digital transformation deployment compared to other sectors like for example, the financial sector. So with every challenge, there are ways to solve it. In Aramco, anything we do, it has to be in a proper, you know, properly designed in terms of architecture to make sure that all these, you know, defense systems are already embedded in any solution or a platform that we design, whether a connection with cloud or internal within Saudi Aramco. I hope I answered you, Shakir.
Okay, thank you. One more question, one last question, Mr. Nabil. This is a question by Zishan Khan. You talked about robots replacing workers in the industry. What about the coexistence of humans and robots? Again, are there any security issues?
This is what we call the bionic, you know, operation. So they have to work hand in hand. I'll give one example: the RPA, the robot process automation. The way we deal with the RPA, as if it is a digital worker, it has to have probably you know, an ID, employee ID, and it has to have a boss. So you cannot just implement RPAs to do a specific functions, either for finance or HR or the facility, unless they have a boss. So somebody that really monitors, you know, their operation. And RPAs or any robot will definitely, you know, if there are issues related to cybersecurity, it's already embedded in your system. You already take the cybersecurity in place. I think the challenge, in my opinion, is if you deploy these type of robots, especially RPAs, which is nothing but softwares that they do certain functions. Let's assume that, you know, there is a human being, a number of human beings that they take, you know, the daily plans, and they take in an Excel sheet, and they start communicating these daily plans, and they wait for a response whether these tasks have been implemented or not. If you replace it with an RPA, sometimes there are changes in the work practice. So, you know, unless the human being supervises this RPA to change the task list, that can create chaos. So I fully agree. It has to be a human being and the robots in the form of software like RPA or physical, that they have to work, hand in hand to address specific business activities.
Okay, thank you. Can we take one more question? So there was one question from a panelist, Mr. Yasser AlSaied. The IoT machine-to-machine data scale needed to enrich AI and have seamless operations to much different roles than the personal and financial data, which you can manage by country rules. So his question is, how can we apply different rules to guarantee the advancement and scale needed for IoT?
So are you talking about device-to-device connectivity?
Yes. So yes.
Yeah. Okay. But you remind me of, if this is definitely, we in the oil and gas, we are known to be extremely reliable. Making sure that we don't want device to device to talk to each other and make decisions without, being checked, especially in the oil and gas. But there are other, a lot of applications, and one of them, in my opinion, is what I have in my home. And I try to bring Nest, fire alarm, and and this is really very surprising. You put these fire alarms, and they are nothing but a family of IoT devices, and I think Dr. Saggaf mentioned it in the beginning, that they talk to each other. So if there is a smoke in the kitchen, the whole family will start making announcements, and through Wi-Fi. So they talk to each other, as a family. Whether this will be implemented in, let's say, in the oil and gas, and this is something will definitely have to be make sure that it has the right protocols, the right, architecture, the right, policies. But there are many applications where different devices have to talk to each other. For example, in a smart home, there could be, areas that, different devices talk to each other, especially in the autonomous operations for vehicles, where the smart, IoT in the car will be talking to others, IoT devices on the highway that, talk about, crowd or congestion and 3-4 miles away. Definitely, there are a lot of applications. When it comes to the oil and gas, with their device-to-device, they talk and make decisions. I think this is an area that we see it coming, but it will require clear standard that's, in my opinion, is not available yet. If I understood the question correctly.
Yes, to a great degree. Thank you very much.
Oh, thank you. Thank you, Dr.
I think, again, on behalf of Computer Engineering Department, I would like to thank you, Mr. Nabil, for accepting our invitation and giving us some time in your busy schedule. We have a lot of questions, but I think we will save them through the panel discussion. I know you have other commitments, but please, if you can stick around to the panel discussion, we much appreciate that. Thank you, Mr.
Shukran. Thank you for the invitation. Thank you very much. Thank you.
Okay. Our next speaker is Mr. Murhaf Almadani. Mr. Murhaf Almadani is the Vice President of Corporate Digitalization Program at SABIC. Mr. Murhaf is holding a PS, Bachelor of Science in Computer Science from KFUPM since 1990. Mr. Murhaf holds also different positions. He's the chairman of the board of the Saudi methacrylates company SAMAC. He's the chairman of the board of National Methanol Company. He's a former member of the board of Arabian Petrochemical Company United, and also a member of board audit committee in the same company. Also, mashallah, he holds several positions in different companies. So without further ado, I would like to welcome Mr. Murhaf to give us his keynote speech. Floor is yours.
Thank you, Dr. Muhammad, and good evening to you all. Do you hear me well?
Yes, I can hear you loud and clear.
Okay. Thank you. And thank you, Abu Ahmed, for the inspiring speech. You're raising the bar high for this aspirational ambition. I think this is really great to see Aramco doing that. Definitely, it's going to be a great guide as you move with this journey. So thank you, Abu Ahmed. Again, I would like to thank the organizing committee for inviting me tonight. I think this is a great exchange of information, and I'm happy to see KFUPM really taking the lead in such exchange with the globe. Let me start. My topic today is digital transformation within SABIC and the role of IoT in this journey. So, which is our topic for tonight. Let me take you back. My agenda is going to be simple, introduction, and then the high level of what is the SABIC digital transformation journey. And then I'll talk about the IoTs and the industrial IoTs, a closer look at the differences between the two. And then how did we really utilize the IoT in the industry and specifically in the manufacturing, and dive deeper into a use case and specifically called the asset healthcare. So with the introduction.
Mr. Murhaf, are you sharing the screen?
Sorry for that. So let me see.
Yes, we can see it now. Thank you.
I can see it?
Yes, we can see it. Thank you.
Okay. Okay, so this is what I was, my topic, so the agenda. And I went through it, so sorry for the mismatch with the slides. So let me take you back 1784, and specifically for the first industrial revolution. This is the first industrial revolution where mankind have discovered the power of the steam. And here is the steam engine era. Almost 100 years later, the second industrial revolution came about, and it was about mass production. And the first assembly line was in a slaughterhouse in the city of Cincinnati. Almost another 100 years, the third industrial revolution came about, and it was with the introduction of programmable logic controllers. Almost half a century later, we have the Industry 4.0 defined in 2013. So let me take you from here with the Industry 4.0, which is the convergence of digital technologies with the physical assets. Very much it's referred to as smart factories. It uses multiple areas like automation, Internet of Things, our topic tonight, big data, artificial intelligence, machine learning, and advanced analytics. In SABIC, we define our digital transformation journey as the business changes through the use of digital technologies and data insights to create business value. Very simplistic, but very deep. Let me take you on how the IoT is embedded within the entire process of the digital transformation. Starting with the Internet of Things, basically it forms the foundation where we are connecting and collecting data. And then simply it is stored somewhere as in a big data platform, and this is the storage of it. And then we take that data, apply advanced analytics, machine learning, and artificial intelligence to really analyze and come up with more insights. And finally, present that in a form that can help decision makers to come up with business value. If I look at the IoT, again, it's all over our life today, whether it is in our pocket, being the mobiles, or in our houses, or in our factories. And it comes in a structured and non-structured data, whether it is temperature, geolocation, an audio or a video, or maybe accelerometer. It can be anything. And that's really how we are overwhelmed today with the technology all over us. As we capture that data, we apply on top of it the machine learning and artificial intelligence in order to help us with multiple use cases. Those use cases could be predictive maintenance, smart production planning, process optimization, supply chain optimization, and the R&D product design, or in a customer experience, and many, many other things. And finally, that would be presented in a form that could help decision makers to come up with the insights could help decision makers to come up with business value at the end of the day. That was a simple introduction around the IoTs. Corporate digitalization program in SABIC was launched in 2019 and was set to unlock the power of IoT, big data, machine learning, and the rest in order to improve our competitiveness and strengthen our leadership in the chemical industry. The program has three objectives, namely the first one, leveraging advances in digital technologies by capitalizing on artificial intelligence and machine learning, enable SABIC to become a more data-driven and proactive company, and shape SABIC future for years to come by transforming the way we do business, drive out inefficiencies, and enhance customer offerings. In 2019, we came up with a 5-year digital strategy. That digital strategy, we started the execution in 2020, and simply the areas that we have initiated was manufacturing, procurement, the Bitchem and agri-nutrient. Those are the profit centers in SABIC, if you will, the SBU's strategic business units, and the TNI, which is R&D. Despite the pandemic and the lockout in 2020, we managed really to do a lot of mileage in those remotely and virtual. In 2021, we continued also with the lockout, and we started scaling up successful pilots, and we launched additional pilots. Next year, we are going to scale up also the successful pilots and continue with the rollout of the entire pilots that we have succeeded to do. Now back to the subject of tonight, the IoTs and the IoT, industrial IoTs. So maybe starting with a definition. So let me say, what is IoT? If I look at IoT, there are too many definitions around, and every company is having their own definition. In a nutshell, they all mean the same thing. But for the sake of our discussion tonight, let's have the simple words that IoT enables different types of things to connect to each other and share data or perform specific tasks. There are, as we said earlier, IoT is all over us, in our pockets, in our homes, in our factories, and it's becoming in our appliances. It's all over the place. But there are different IoTs out there. The Internet of Things that used for consumers and business, and there are the industrial IoTs that's a little bit different. And maybe for the sake of IoTs for tonight, let me illustrate some of the differences between the two. So from usage perspective, the normal IoT is widely used by generic consumers across different business sectors, while the industrial IoT is used in industrial sectors such as manufacturing facilities, oil and gas, mining, and etc. Whereas the ecosystem for the IoT is widely available from a big number of providers today. But if we look at the industrial IoT, it's manufactured by specialized companies, and sometimes those are very niche scale companies. Working environment for the normal IoTs, it's designed to be used in normal consumer environments, while the industrial one is built to be durable, reliable, and withstanding the harsh working environment. Power consumption, batteries efficiency is a plus, but not a must due to the ease of charging. While for industrial IoTs, batteries are built to work for long times, up to 10 years. The purpose of the normal ones are basically mainly to enhance user experience and every day in life. It's for comfort, health, safety, etc. While the industrial IoTs is to increase efficiency, safety, and health of industrial assets. So being from manufacturing, maybe I will talk only about the industrial IoTs and how did it really benefit us and really in our transformational journey. Those are use cases that we have embarked on, whether it is a predictive maintenance, and namely asset healthcare and digital twins, or a precision monitoring and control, plant efficiency and energy optimization, or for using smart inspections for corrosion monitoring and leak detection and other stuff. Connected field worker to enable our field operators. The added value is basically to improve the efficiency, minimizing downtime, and also cost reduction, in addition to enhancing visibility and smarter decisions. For the sake of an example of what we have done, I'll focus more into the asset healthcare as one of the examples that we have worked on. So let me drill down. This is a typical site. This is an actual site in Saudi Arabia. As you can see, it's illustrating the availability of IoTs all over the plant, whether it is wirelessly or wired IoT, to give an illustration. So it was very important for us to make a connectivity. As I illustrated in the beginning, it's a building blocks. So we're starting with the IoTs. We have those IoTs are simply sensors in our plants and our equipment all over the plant, and they all go into what's called historian. So we connected the historians of all our plants, whether it is in KSA or in America or in Europe, all of them into a centralized big data platform. Wealth of manufacturing data all together have been gathered and today it's real time streaming the data as we go. Initially, we picked up all the history. We have a 15-year of history that helped us in digging deeper into the analysis. So having that as the foundation, I'm giving an example here for 3 sites that could be in KSA, Europe, or in America. We took the assets historical data into the big data and then built a model for those particular equipment within that particular plant. Of course, we look into critical equipment within the site itself. We built a model that learned the history and how failures happened in every equipment. And then we streamed the real-time data into the model so that it would give us real-time alerts whenever there is something happening or an anomaly that could happen into our plant. This has yielded a wealth of insights into what could go wrong beyond all the alerts that's already available today in our plants in the past. The chart here shows the y-axis shows the asset condition, and over time it shows how the asset of whether it is a particular equipment or a collective equipment how it would deteriorate over time until it gets into a failure. If we look at the control rooms, usually without the asset healthcare, this is what it gives us. We have a limited room before the actual failure happens. So when it is detected, it's detected a little bit late in the game. Whereas with the machine learning, we were able to detect way early if there's an anomaly happening in a particular equipment that could lead into a failure at certain time. That gave us the early heads up to look into a specific equipment, monitor it as we go, and also prepare that we do a repair, inexpensive repair because it's early repair, and plan it well so that we are preventing either an unplanned shutdown or a very expensive repair. That was very insightful using simply the IoT, industrial IoTs as the raw data that we are collecting. Excuse my bird here, but somehow it's 7 o'clock in that clock. Let me just wait for the noise to go. So as you can see here, the extra lead time. In certain cases that we have discovered, the early alerts came almost a year before a failure happened. So that much of extra lead time. Of course, not always a year, but it gives you way heads up into what could happen as an anomaly. So the entire thing does not really come without a challenge. For our advantage, there was a lot of wired instrumentations across our plants. There are areas we need to install more IoT, industrial IoTs, but in general, there is a lot of wired that helped us capture a lot of data and really make a lot of mileage in our journey. Still, there are challenges because we still have certain instruments and equipments that we need to install industrial IoTs. So if we look at that, mostly it's going to be wirelessly, but connectivity infrastructure is still a huge footprint for our existing manufacturing facility. 5G is designed to serve this purpose, but still in the very early stages of actual deployment. It's a challenge, but it's going to be tackled. The second challenge is basically compliance with safety and security standards. So due to high risk and classification of many areas in petrochemical, plants, only certified devices are allowed to be used inside these areas. The third is basically the industrial IoT ecosystem availability. There are limited availability of industrial IoT devices that meet safety and connectivity requirements. It's a challenge, but it's going to be met. With that, I conclude, and thank you very much for listening. Muhammad, back to you.
Thank you, Mr. Murhaf, for the very interesting talk, and I'm really happy to see IoT in action in some of your sites. So we have a few questions, but I think we will save it to the panel discussion. And for the interest of time, maybe we can introduce our next speaker.
So I'll stop sharing. Right.
Yes, thank you. So our next speaker, our distinguished speaker, is Mr. Yasser AlSaied, who is excuse me, let me hide this panel. Oh, sorry. Okay. Mr. Yasser AlSaied is the VP, Vice President of IoT in Amazon. Mr. Yasser AlSaied have more than 27 years technical and strategic and executive leadership experience in different companies in North America, including Amazon, Qualcomm, AMD ATI, Philips Electronics, Nortel. So Mr. Yasser studied computer engineering in Ottawa, Canada, and a postgraduate certificate in engineering management in 1997. It is worth saying Mr. Yasser grew up in Riyadh in his first 20 years, and then he moved to North America I think without further ado, let us all welcome Mr. Yasser AlSaied. Mr. Yasser.
Thank you very much, Dr. Muhammad. I think, let me know if the voice and is going on okay with you?
Yeah, your voice is loud and clear.
Okay, excellent. So I've actually had this invitation a few weeks ago, and I was thinking, I have hundreds of slides I can, patch together and show, and I thought the audience, and that's why I asked the audience the first few seconds in my connection. I said, who is the audience? Mostly students and grads and so on. And I thought the best thing to do is actually to share my some of my definitions of the IoT and in actual world where the business of IoT has been going and then where it's going to go in the future. So, but couple notes I want to start with, which is very relevant because of the fact I see some names here today in the panel and how in fact I came about to this event, which I really appreciate. The university have put it together. It's very, the most important thing actually to connect academia to actual projects and where the industry is going, because first of all, it excites the students. That's the first thing. And the second thing, it actually makes sure that the academia research solve real problems that by the time you will have the engineers working on it, then it will be the relevant time to actually deploy it. So I decided to have no slides, but rather quick talk and then look for the panel discussion and questions. So the one point I want to start with is just a word of advice to the students, undergrad or postgrad, is make sure you keep your connections and friendship maintained as long as it takes. So for me, it's been 27 years. But I noticed some of the names like Dr. Ammar Enaya. He probably doesn't remember me, but I remember him playing soccer in Dhahran. One time I visited the university with a couple of friends that among the attendants here today. So that's interesting stuff. So, and also back 33 years ago when I grew up in Riyadh, it was very interesting to come back and visit Saudi Arabia after 31 years of not visiting when I did in 2019. So imagine leaving it 1988, 89, and then coming back, no visit, nothing until 2019. And I was astonished with the advancement, astonished with the ambition, with how the young people looking at the future and involvement in the technology. And it gets me so excited to see this even more and more. And this event was, I was so keen to actually participate, even it's like pretty early in a Sunday morning. And so I appreciate that. So that's enough for my intro. So I want to get back to IoT, really. And my involvement in IoT is probably 5 years old right now. Actual work, actual projects, like rubber meeting the road, where we say like real things actually being built. I see one of the panelists you're going to say here later, Stein, is one of my colleagues, very close colleagues in Qualcomm, my ex-employer, before I moved to Amazon. So he'll have interesting point of view that I will keep that for him to share. But IoT history is actually not new. It's nothing new about IoT, except people start to use the word. There's a lot of things new, which I'm going to mention. But if you can remember, I don't think any of the students can remember that, but let me throw it out there. You know the pay phones, right? The phones that you put coins in and actually it works. Those back in Nortel, when I was in 1997-8 timeframe in Nortel Network, which is Northern Telecom used to call then Nortel, there was a huge advancement in that technology that actually the phone will call the coin collector to come over and collect the coins. So basically, if it filled up with the coins, you can't use the phone anymore because there's no space to put a quarter in, or like a 10 halala or something like that. I don't know how much it was before. Because before the cellular phone, the pay phone was the mobile phone. You can stop the car and you can use it, and people, going to Hajj or going to shopping and so on, you can use it. That's really the mobile phone. Before people had the car phone, which used to cost, I remember my friend in high school, They had one installed by their family. Of course, their dad. It's probably like 100,000 riyals or something like that. Really, really expensive. So that was a form of IoT. That's actually where you had a machine, the phone, telling the data or like central office or the management system that back in the phone company, come collect money because I'm full. So that's an IoT. And many other things like that. But it was limited to what I would call very thin vertical, extremely thin vertical. So a very specific use case that has a design from end to end specifically for that use case. So all kind of engineering, all kind of programming, maybe specific protocol. And I'm going to talk about protocol a little bit later, where there was a specific piece of software that was written to actually handle this specific code, which I know for a fact it was a specific software that run only for specific, and let alone if it's this phone or the phone in France or the phone in like different place in the world, it all have different pieces of software. So it's very thin vertical. You cannot deploy it anywhere else, but it solves a problem. And the IoT we're looking at right now for the past, let's say 5-6 years, is a completely different scale. And why is that? Why did it become so big scale? And Dr. Naeem from Aramco, I wrote down a word he said, which it's a different than what I would use, but it's actually very applicable. He used the word hyper automation, and it's actually smart. Hyper automation, it's like hyper scale, but why this is explosion of use cases and explosion of ecosystem? It starts with the internet, actually, the connectivity. So the key element to allow such explosion of use cases and possibilities and verticals that we didn't even, there's stuff we even don't know. And the word that one of the famous bosses of mine, Jeff Lorbeck in Qualcomm, used to say, we don't know what we don't know, actually. So that much how IoT is so cool, so exciting, because you are working in a place that in the coming 10 years, you're going to still discover new things, and there will be still new patterns and new industries that will be involved. So IoT history we talked about, why it's exciting, because of the scales, the goals. Let's talk about the goals for a second. So is the goal making money? Of course, always goal is making money. But in parallel with the different of this one, the goal is actually saving human life, human health and security, the environment, catastrophes, health, many other things. And I'm going to throw some examples about so you can understand the goals. So what we say, أجر وأجرة, you know, أو بالحجاز بيقولوا حج وبيع مسابح or something like that. I still remember these things, by the way. حج وبيع سبح or something like that. So if you think about like I have this embedded, which is a sugar meter, you know, by Abbott. It's a very simple IoT. And it's using like RFID and Bluetooth. It's very simple. But the point is, when I scan it with my phone, my doctor gets the curve. And my doctor, after like say a week, say okay, give me a call. I need to see you, because he's been seeing the curves of what's going on with my sugar, if it's managed well, if it's spiked, if there's a problem, or if there's a dangerous problem. So they have the whole history without being in the office for like 2, 3, 4 months even in his office, or take a blood sample even. So imagine that. Another example it was striking, really for me, touched me, is in the Amazon. So I went to Sao Paulo a few times. Brazil is one of the largest, I would say, possible market for IoT, simple devices, things that are $5 and $10 a piece, not hundreds of dollars. And one of the things I saw that used the LoRaWAN is a network of using mesh network. A mesh network is mesh topology is something I don't know if many of you know, but it's basically like how you connect things together to basically connect the connectivity technology together. Like let's say you have multiple points in the house for the router and the APs and satellite APs and so on. So these things. So they connected those LoRaWAN very simple devices in a mesh network alongside the Amazon jungles and highways, simply to watch temperature, humidity, and if there is a fire. So what this happens, imagine a small fire starts, if nobody sees the smoke hundreds, maybe not meters, maybe like a few kilometers away, if there's no smoke signal, the fire brigade will never be called upon, or there's no, that's why there used to be concept of the towers, the jungle towers. So these LoRaWAN devices that's across the area will let each other know that I am seeing a smoke. So things that will happen, they shut down the electricity so the electricity doesn't get explosions in the transformers and so on. And this will ripple effect as safety measures that basically a human will program, including calling the fire truck to actually come in and start taking out this fire. So imagine the goals of these things. So now, where we say we as I said, we don't know some use cases that we discover as we come along. Okay, so let's talk about reality and where is the value chain, because my topic, as I thought about and gave it to the panel, the event management here, I said, I'm going to talk about money. And actually, I'm not talking really about money, but I'm going to tell you where the value chain is and where the money is. So as you form your future plans and as you focus on, okay, what I'm going to do in minor, what I'm going to do in my thesis, where I want to go look more in research, you can see the balance on this area, what's your passion, because something we have in us in the Middle East, that we sometimes have priority on expectation from family or community versus the passion. And I'm strictly talking about career in the high tech. I'm not talking about passion, okay, I want to like have a car race or something. No, I'm specifically talking about the career and the high tech and where the passion is. Because some of us might be passionate about building the hardware, or, playing with the latest piece of hardware at home, Raspberry Pi, and building stuff from it. Some love to write applications, some love to program, and you need to discover your passion, then go at and develop that. And the IoT have all of that. Where? So IoT consists of, if I look at what plays part in the value chain of the IoT, you have devices in the language I'm talking about is like cameras, robotics, vehicle, and so on. Sensors, by the way, on the vehicle note, I drove 2 weeks ago, part of like a very small group who's try a electric car, very advanced electric car called Rivian. It's a truck. So Rivian, the VP of software, he's actually a Tunisian. He's a Tunisian from the Bay Area. He was telling me this is an IoT on wheels. So imagine the scale between a sensor that's 10. I need to be always reminded on time because otherwise I'll keep going. So the IoT on wheels is, or like imagine the smart meter, they have the $5, $10 module as an IoT machine to machine, but this is an IoT on wheels that's cost $70,000 because it has all the technology needed: sensors, cameras, data collection, GPS, location collection, accident avoidance, etc., etc. All the vehicle, what the vehicle got. So that's on the devices. Then you get sensors. Sensors is the ocean by itself. You get sensors for environment, sensor for weight, sensor for vibration, sensor for many things. And the sensor technology is becoming so advanced. I had a meeting with the CEO of TDK a couple of weeks ago, and he was telling me about, it's announced, so it's not a private matter. They are putting sensors in way that it will charge itself because of the application it's going to be in, that you will never have to replace battery for life. So generating things, and I'm not going to go too specific because I'm not exactly sure where is the line on the patent filing, but basically generating power because of the mechanism that this sensor will be operating under. So imagine no battery needed for an essential sensor that can handle, for people like Stein and the people who actually have ARM processor kind of exposure, it will handle even AP. and a memory to actually work with. So imagine that's fine. Here's another pattern. Okay. So that's on the sensors. And then the camera and the world of camera. And when I did the tenure in Qualcomm on the IoT, beginning of the world of IoT, we were actually rowing in a very muddy water. We don't understand exactly what to go for after, because everything could be IoT. Okay, so what do? We do the small cell, we do the towers, we do the, what do we do after? And then we stumbled across camera device. And we found, and the world found by now, that camera vertical for the IoT is one of the most lucrative used application on almost the 360 degrees of the IoT. So the camera technology doesn't include just this lens, doesn't include the streaming, it includes everything. It includes the environmental reinforced cameras. It includes the very, very low current camera that actually can record the pre-seconds of the actual image, trigger image, and so on and so forth. So security, personal, industrial, military, you name it. But the most exciting one that I was involved in, and Qualcomm, is the one in Mars. Like Stein probably knows this, the helicopter and the rover. We got 7 chips from Qualcomm actually in those applications, which basically makes things even more exciting, specifically on the camera. Then the next one is connectivity. There is no such thing as called IoT without connectivity. 30 years ago or 40 years ago, it was connectivity by wire. You remember the example I had with the payphone. So imagine now with 5G and the millimeter wave, and the fact that millimeter wave is actually more than 4 kilometers or 5 kilometers now, in some kind of like an insane range with this high speed. And I'll leave this to actually Stein, so I'm not going to talk about it. I can talk about cloud right now. So the connectivity is a huge thing. And then the last but not least is the cloud, or the background, basically the back end. The cloud is the brain of the cells, the end cells of how is the brain and the body, the cells. So you can have very smart, intelligent, where the eye, the light sensitivity in our eye is a decision on the eye itself. Subhanallah, al-Khaliq. Yani, the intelligence of how much it will open and close is an immediate based on the cells that Allah subhanahu wa ta'ala have created in the eye. And that's an edge AI. That's where the edge AI. But most of things like I'm hungry, I'm tired, I can feel the heat, I can feel the pain, it goes up to the brain to make a decision on what to do. So imagine how many trillions of nerve ends we have in our body and cells, and it ends up in either decision making, so it's a smart edge, or it connect to make a decision in the cloud and come back with a decision. This is analogy I actually copied from my friend Ammar Hassan Kamel. He's in Dilla, and he repeated it in front of many meetings. And I actually told him I have the license to use this analogy because it's excellent. No, subhanallah, this is one of the things that we see in our bodies that show us how the technology would be if you think of later. So if you think the people would think about patterns, how the amazing human body that created by Allah subhanahu wa ta'ala functioning so well and so to the highest degree of precision. If 1/2 degree or change of temperature happen, what happened to the body? If 1/2 of chromosome is gone, what happened to the body? So imagine the precision of that. So we have a great example of IoT ecosystem, but it's even much greater. However, that's what tells you the scale we're talking about. Okay, enough of this one. How about R&D, where the R&D is being put? This is again another tool for our undergrad, postgrad, and people who is actually thinking about career. And this regard, what regional I'm targeting for, I'm targeting in general, because Saudi Arabia have actually specifics that is actually, in my opinion, I'm not biased because it's Saudi Arabia, but in my opinion, it's the most opportunist land to actually grow in the technology. There is the space, there is the gaps, and there is the will and the wealth to actually support a very quick advancement in areas that the other places in the world would not dare to touch. And I'll give some example. So where is the investment mostly in this industry happens? So there is, I call it the R&D or the investment. So in oil industry, as you are the master, so I dare to touch the oil industry because I will say all wrong data. So I'm not going to touch that. But in the drilling though, in the oil, you're going to have investment into making the business, which is the drilling, this and that. There's multiple steps to understand, okay, now I'm getting to ROI, that if I get out the oil and sell it, I'll make the money. There's sometimes very cheap, sometimes extremely expensive, like the case in the way that they take out from the sand, oil, and the rocks and so on, how it's very expensive to take out. So in IoT, if I look at hardware, connectivity, and software or apps, so that includes actually the cloud. So we're talking about in the cloud, software and services of the cloud, it's about 66% investment. So remember when the previous speaker, I don't know which gentleman talked about, there's the multi-cloud and there's like investment into how to connect the use cases to the services and so on. That's a huge, huge area that's still growing and still being built. And I'm right now involved in, it's just an ocean of things. It's a scale that I never imagined would be that big, but it is huge. So in reality, I looked at it, the data, and I found the investment in R&D in that area is about 66%. In hardware, so the hardware, including the chipsets and more modules and devices hardware, is about 26%. It includes the embedded software in it. And then you got the connectivity piece. So how to connect. So that's mean with cell, with Wi-Fi, with other technology, it's about 8%. And why it's small? It's interesting why it's small. It's not because it's not important, because there is only very, very few companies in the world who does this well. So in the scale of things, who's investing and what, you'll see like very small numbers doing the connectivity. Therefore, it's the 8% of the, and that number is fluctuate every year, of course. And then the hardware and software, embedded software is about 26, and the apps and cloud is 66 because it's a huge area, because again, it's the brain. So looking at the time, I just really want to double check.
Yes, if we can wrap up in a couple of minutes so that we can have more time discussion.
Okay. So definitely. So let's see. I want to choose my, okay, great. So what are, in my opinion, the challenges and risks that we need to look at, and which is opportunities to grow from? One of the very relevant area to where we are talking and the crowd that we have here is the multi-protocols of industrial IoT. So we got almost 40,000 mega factories in the world, including refineries and so on. And as this industry grew in the history, there was, again, back to a specific vertical solving a problem with a specific solution that's customized to certain, let alone factory type, but even company. So every company have their own protocol, their own platform, and they developed, and now it's running. It's a very well-oiled machine in the factory that nobody wants to touch. But imagine you got 40,000 of this around the world. And now you are imposing, or everybody's running to IoT and real IoT, which like wireless connected, cloud back end and so on. So these protocols have to talk to each other. So here's an opportunity. We need to look at things, how to connect the new world of connectivity to the cloud with the old world of this machine controls that we have hundreds of protocol language that they're running with. So you have a space for students and graduates and researchers, how to actually connect this seamlessly with all these protocols that's running. The other one is security and 100% operation. Now we're talking about, we're gonna all depend on each other and connectivity and the cloud. So imagine you are running, and I'm gonna take an example of bank. Okay, just bank, banking and stock exchange and moving of money, and some hiccup happened in this value chain somewhere. The second is multi-million-dollar. Who's gonna answer to the head of bank that I lost $100 million because of some Bluetooth connectivity hiccup somewhere? So the guaranteed 100% operation and security is an absolute challenge with this multi-protocols, multi-vendor, multi-vertical that have to work together. How you can guarantee that? That's an area. Nobody still have this figured out. And I think it will take many years to get it where it is the industry right now. Last one, smart connectivity for cars and fleet. How the connectivity will have to be figured out on moving object, fast or slow, remote or close in like smart city. My first question today to Dr. Naim was the data, to guarantee the data. So think about an oil tanker leaving the port outside the country, data protection rules and rules of engagement. How can you still have a tab on the tanker all the way around the world with the exact data you need for collection analytics and vice versa? And the tanker coming in, understand the traffic on the port, the available of the pumps, etc., without the boundary. And I'm talking machine to machine data. I'm not talking about personal, your blogs or picture or bank account. This has nothing to do with that. That's a different data. I'm talking machine data to have the security and operations smoothly. That's it. I have so much to say, of course, but the time, thank you very much for giving me time, Dr. Muhammad, and I yield to the next session.
Thank you, Yasser. Very interesting discussion and talk, and I pretty much like the analogy to the of IoT to the human body. I think let us start our panel discussion. I think we have a few questions from the audience. So I'll also ask my colleagues in the panelists to maybe step in if you have any questions to our distinguished speakers. But let me pick one question from the audience. I think, Mr. Yasser, you talked about connectivity. Also, Mr. Murhaf, you talked about sharing data between facilities or different facilities at SABIC. So one question here is really how to share such industrial data between facilities and move it or migrate it into a common center. Is it through particular technology or is it through partnership or legal aspect? So if you can shed some light on this.
Yeah, well, this is usually a dilemma. The easiest path that we have approached, first, our business network is a global network. So our entire, landscape is well connected from business network perspective. Usually the OT environment is a separate network for the plants. So what we have done secure connectivity between the OT environment and the IT environment internally, and we pulled the data in one direction to the central historian, which is an on-premise Hadoop platform with a lot of tools on top of it. But our data did not leave the company. In a simple, yeah.
Do you wanna add a follow-up, Mr. Yasser?
Yes, of course. Thank you. And this comes, Dr. Murhaf, on the specific application area, which is very well understood because a lot of corporations have actually the same thing. When we address factories for automotives and so on, this is very important, and the industry is addressing that. However, my answer to the question itself, I would say all of the above. So if you look at all the list that the gentlemen have asked, I forgot the name that you mentioned, is it legal? Is it rules? Is it the connectivity through wireless? Is it how? It's actually all of that. That tells you how complex the problem or the challenge or the opportunity is to be addressed. And every company needs to look at it holistically, because otherwise you'll have a blind spot. And the moment you have a blind spot, in operation you fail, and those are the seconds actually we talked about that you lose money in.
Yeah, I fully agree. Again, when you work in a project like this, you always have your legal working with you for legal aspects, because you are crossing borders every time you're doing something somewhere around the world. But we have simplified it by using our internal network. If it was that we have to send the data to a cloud environment, it would have been more complex or more issues with governments and regulatory bodies, but having it internally within SABIC, that simplifies it. But still, you have to go through a lot of legalities. And in certain occasions, you have to get certain approvals from regulatory bodies. But to keep it simple, maybe I'll take Yasser, analogy. It's all of the above. You need to address all of these. Yes.
So, okay, thank you for your answers. Another question from the audience. I think maybe this is actually for both of you. The question is: do we consider industrial IoT as a mature technology when used in industry?
Well, industrial IoTs are more robust. So once you deploy them, they are built for that particular environment. And as I said in the comparison slide earlier, they are built for a specific purpose. So they're well tested and so on. Doesn't mean that they don't fail. So you have to always monitor your data. And if there is something inappropriate, you have to go and check if that particular IoT is defective or you need to fix it or something like that. So that's part of the game. I mean, nothing really works perfect all the time. So I see a question around the foreign companies. Well, SABIC is a global company and owns sites across the globe. So those are our companies. And this is when I said we go through legal aspects. That's the legal aspect we go through it. But again, it's wholly owned companies by SABIC. So it's not really a foreign company, it's a SABIC company. But there is legalities, of course, because of cross borders and some data. The beauty of it, most of the equipment data and so on, it's not really that sensitive because it's for a specific device, much similar than other data. But still, you need to go through a lot of legalities in order to do it. Having it within the premise of SABIC have simplified a lot to us.
Interesting. So I have a question for Mr. Yasser. So talking about reliability, industrial IoT, and so on, there is one specific question directed to you, saying, would you go for physical, like when we talk about reliable industrial IoT, would you go for physical redundancy or for analytical redundancy to reduce high investment cost?
So when we talk, did I understand the question? Analytica in the redundancy?
Analytical, so physical redundancy, or I think he's saying application redundancy, analytical.
Yeah. No, I get it. But the word physical, we have to qualify a little bit here, okay? Because physical is actually, in the practicality, it doesn't mean actual physical wire. We're talking about the physical layer, and it could be wireless, okay? Because wireless became very, very long way by now, and the investment that's been putting in wireless, and I said this is a session they will hear later from my colleague Stein, is how reliability, availability, and quality of service has been guaranteed to make sure address the industrial use cases. Because one of the major point that we have to always keep in mind in the industrial IoT, the IIoT, is the economics, the money. It's really about the money. The factory stops for a few minutes, it means a lot of money loss and revenue and cost. So the more investment the solution provider or the system integrators or the actual factory operators, more investment to put in redundancy of operation, which is physical, the more guaranteed they can have a flow of income, flow of revenue. The analytics or the apps, or so there's two pieces. The cloud has to be the same, because the cloud, you cannot shut down the brain. Like if you shut down the brain, of course, some stuff might work, but a lot of stuff will be really in catastrophe. The middlewares where the apps are, you have to build the redundancy system, of course, and the robustness. In the end, the industrial space has to be like a spaceship, working like a spaceship, like Apollo 13 movie, how things has to be so particular. The consumer is very wide, because security application consumers also has to be very, very robust. You cannot have that. But some stuff like didn't work the first time, I scanned it the second time. I mean, I'm still standing, the sky didn't fall. But the engineers should not aim for that. The engineers should aim for perfectionists, because people who studied in Canada, there's a ring that the engineer, the hardware, you know, because of the bridge that fall, and they, you know, make you carry the chain and drop the chain, and you know, because there was a bridge that fall and killed people, and they want to remind every engineer with a ring that's made for that from that metal. Remember when you do a design that you can carry life with it. So the engineer should not aim for not perfect redundancy, but also it depends on the application. If it's a toy or something, you don't want to build a spaceship every time you do a project.
Right. So redundancy is indeed important. Yeah,
absolutely.
I think there are a few questions. They're, you know, a little bit worried about cybersecurity. When we talk about connectivity, hyperautomation, cybersecurity is always an issue. So one question is, are there any standards to control and standardize the integration between hyperautomation and other computing aspects like cybersecurity, for example? So we're talking about if there are any standards from IEEE, from whatever standardizing organization, to kind of standardize this integration between, you know, IoT and different components.
So I'm going to do very like 20 seconds or 15 seconds on this. Yes, there is a lot, and it's being put together. And I really want to keep, I don't know if Stein, are you addressing this in your talk, Stein, or not? I'm not sure. You're not. It's a big C. Yes, there is standards on how the data is handled, the policy, the authentication, as simple as application. Like for things like I am actually touching every day in my own in my work, is like a simple alarm system in the house. I think, is it Dr. Murhaf, you talked about Ring or Nest, or maybe, or Dr. Naim. So these things, as simple as it seems, like, oh, I'm gonna alarm my house, I'm taking the alarm in my house, or watching the camera, these data path that goes between the cloud to the carrier to the, they have their own security package that goes with it, and it has to have multiple corresponding. So, but each connectivity protocol with the cloud or with the telco or with carries a standardized security, because otherwise it cannot talk to the network. Just a second, this is to something I don't have in Seattle. I'm in San Diego this weekend, so okay. So these protocols are actually to a high degree standardized, because if they don't, the packets will not talk to each other. You know, MQTT and those different protocols that's used. I said 15 seconds and I kept going, so go ahead. I hope I answered the question.
Yes. From my side, I will look at it from a different angle. Simply, as you deploy new solutions or new connectivity, you have to vet it through your cybersecurity team that this connectivity is secure, and whatever need to be done for that particular one. Every solution has to go through cybersecurity checks so that you are fully secure in your entire setup. And that's how we approach it. So we have the cybersecurity team is really hand in hand with every technology that we introduce.
Interesting. So I think there are many questions about security, and since we are talking about security, and there is one question about blockchain technology, so I'll throw somehow a general question. What skills, since we are targeting KFUPM community, and most of them obviously are students, grad and undergrad, what skills do students need to have to be ready for the IoT market, whether it's industrial or maybe it's different applications? So we're talking about the skills that students need.
Okay. I'll take a shot on that one. So we do a lot of recruiting, and I'm involved in a high level, a lot of recruiting. As you remember when I said that the investment in the cloud and software and services, like 60% of the R&D in general. And what do I look with these campaigns of recruiting? Very high skill in software, very high skill in software, but, and here's the interesting one, very high level of creativity on the human interface, the UX. The UX is a used term? Is it used? Okay.
Yes.
So one of the interesting points you see along the line of the industry when they get specialized in certain areas, including tools and programming tools and development tools and dev kits and so on and so forth, when the engineering wizards like start to build things, it becomes so complex sometimes that even another engineer from another region in the world will look at it and will be overwhelmed and leave it alone because they cannot use it. So as much as you need a good software and good architects on software, architect comes a little bit later, but let's say new grads or researchers, how to build a smaller software, smaller footprint. Always think about IoT is small things, it's things. Yes, you're gonna get a car and you have a smartphone and you have areas which you have big memory, but most of the IoT have a small memory in it. And the more optimized code you have, more close to machine you have, most better speed and better mobility between different verticals you can put the software. So you can have one to many. But same token, to grow the ecosystem, you need the right tools and right documentation and right marketing material that the decision maker or the trainee or the factory in China or the factory in Malaysia look at this material, they can actually use it. So one of the major pain you can see from the developer of software and the user of the software is like the user will look at, oh my God, I need a PhD to use this tool. And it's so true, it's a real life. I mean, these are a pain point we learned along the way. So, concluding is the software is big, and I'm gonna bias now for that because of where I am in the value chain. When I was in Qualcomm, a good hardware ASIC design needed to make a smaller chip and cheaper chip as well. Integration as well. That's my input.
Interesting. So software is your keyword.
Absolutely.
Mr. Murhaf. So again, let me repeat the question maybe. So what skill set do students need if they want to go into the IoT market?
Well, generally, academia need to give the broad sense for the IoT. As the graduate, get into the market, he will be able to differentiate between the different approaches, different technologies, because of the broad sense that he got. You cannot teach him something that's very specific. And that's the beauty of the academia. It sets the student to be ready to understand anything that he comes across when he starts, his career. So from my side, I would say the current academia is sufficient. We get students who really they understand in a broad sense what it is. They get into a specific, let's say, a product and so on. They easily pick it up, and then they go from there. Also, it helps them in other occasions where they evaluate different technologies. So that also helps. So already the academia is doing that. So nothing really specific. I would ask academia really to do different from what they're doing today. I think the KFUPM have done a great job. Dr. Saggaf has explained it at the beginning. The AI plus X strategy adopted by the KFUPM is really great, I would say, leap forward to match the industrial needs. They have, KFUPM injected AI in almost every major, regardless of that major, whether it is electrical engineering, mechanical engineering, and so on. That's really great, and that's what we would like the academia to do. Basically, give that broad sense and have everybody AI ready as they graduate. I think that's really a leap change of KFUPM, and I think this is great. We have been hiring newly graduated students, mostly data scientists, and really great quality. So I would say, thank you very much, guys.
Thank you, Mrs. Enaya, for your statement, and we'll be happy to produce more and more high-quality students to the industry. I have one more question here from the audience, talking about digital transformation. So maybe we shift gears a little bit. In terms of, so what does any company need in high-level terms to have a successful digital transformation, regardless with IoT or without IoT?
Well, you need ownership. First, you need ownership from the top of the pyramid. If that does not exist, you'll go nowhere. It has to be the CEO of the company leading this transformation. And that would give a totally different perspective and adoption within the entire company. Any transformation in the company requires a lot of changes. People don't like change, right? That's a human nature. So in order to overcome the resistance that would come across many things that we're doing this for ages, nothing wrong with it. So why change? You need adoption from the top of the, and that's the case when it comes to SABIC. I mean, SABIC is spearheaded by our CEO. And for that reason, I report directly to the CEO for this digital transformation. So that gives you how, those transformational programs need to be managed. That's what I can say for that.
Can I add a bit? I just want to add a bit.
Sure.
This is perfect. This is actually as Dr. Murhaf said, it is absolutely a must. But I want to add one more thing, which is interesting, and I think it's it needs a little bit of preparation for the person, like how you approach things. Sometimes in companies, big or let's say mostly big or medium, because small company, when they're directed on IoT, everybody's interested in IoT. Everybody wants the new ideas. But when you're in a big companies and you bring in ideas that's against the current or outside the core, then you will have challenge if it is not your manager because he hired you to do that, or the SVP or the VP because he's interested in that, is the entire system in the company that will allow you to do that. We talked about legal, finance, even engineering. You need the piece of software that gives you the API so you can build your own stuff. And they resist that. They say, oh, no, that's not important. I'm making money here. Why I should build you this? So I'm addressing this one is like, be persuasive. Engineers, when they have an idea, do not shy away from bringing it on. So for many years, I have mentored new hires, and I was part of the mentoring of the diversity and inclusion within Qualcomm and now in Amazon as well. Is like, you get these bright engineers who've done wonderful job in their academia and the thesis, they did robotics and so on. And you get surprised they can't even put one slide together and speak about it in strength. So address your, not confidence, you are confident. You actually know more than who's in front of you in the subject, because the one in front of you did not even spend 10% or 5% of his time to understand your subject. So when you are a subject matter expert, bringing the new idea to the corporation, be extremely polite. Build alliances with your boss, your colleagues, maybe cross to different department colleagues. Build these alliances and show them the idea you're bringing, understand the language of the corporate so it doesn't go far from where people really talk about, and then bring it with confidence and a lot of real data. Scientists and engineering is all about data. And it's not smoke and mirror. It's not like Viperware. It's not slideware. It's real data that if you bring in and tell them based on this and this, I'm suggesting this. And if we do this, this is the ROI. Very hard to argue with this. The discussion becomes from conceptual discussion to how can we make it happen. So my last word on this, be confident, persuasive, and don't shy away from bringing the new idea, because your generation is what's going to build the IoT for the 10 years to come. And my generation will go to retirement soon. So it's in your hand.
Thank you. Thank you.
Maybe additional criteria for the success of digital transformation. As I said, the first one is basically the top of the pyramid is supporting it and owning it. Secondly, you need to start with the digital strategy. If you don't have a strategy, it's going to be basically you're running in every direction that there is a technology, and that will lead you to nowhere. You have to have a digital strategy. Where do we want to go? What kind of benefits we want? And also you need to have the business to lead it. So it has to come from a business background, what really we want to achieve in this digital journey. And then you leave it to technical aspects, whether what technologies to deploy and so on, in order to achieve a business goal. That's very important. Otherwise, companies who follow technology, so their strategy is technology driven, they go nowhere. It means you are putting a strategy to serve the technology, not to serve the company. So if you start putting in front of you all these fancy technologies and say, okay, we want to implement, let's say blockchain. Well, that's it. Go and pick a problem to solve it using blockchain. That's not the way to go about it. If your business requirement is helped by using blockchain, go and use it. If it's helped by something else, go and use it. But don't have the technology is your target and then follow through. That will get you nowhere. So that's the key points really for digital transformation to be successful. And there is a lot to be detailed, but those 3 points are really key for a successful recipe.
Well, thank you so much for the very interesting discussion. I think we are out of time, but in one sentence, please. I'll borrow some title from Mr. Yasser's title. You said, where is money? And I'm asking you, where is the future? In one sentence, please.
The future for the IoT, you mean, or in general? IoT, yeah. Solving complex problems for human.
Okay. A good one. Mr. Murhaf.
Yeah, I agree. I mean, in healthcare, there is a lot of opportunity for IoTs. And I think there is already certain solutions that really making breakthroughs, but it's not widely used. I think eventually we would see a lot happening, especially in the healthcare.
Okay, on behalf of Computer Engineering Department and KFUPM, we really thank you for your talks and for your insightful comments and discussion. And we'll be happy to connect with you sometime in the future. And again, thank you so much. And it was a pleasure moderating this discussion. I think Dr. Ayman, if you want to say some words.
Yeah, thank you for inspiring talks, very interesting actually discussions, and I'm sure everybody enjoyed them. So now, inshallah, we'll move to the second session. We have the second session, which is titled basically Challenges and Future Trends in IoT, and we have 3 distinguished speakers with us. This session will be moderated by Dr. Nabil Alnuaim, and I will give him the floor to introduce the first speaker in the session.
Thank you, Dr. Ayman. Let me just share the slides.
Actually, can I share the slides? Would that be possible?
Yes, sure.
Yeah, sure. But I'll just share one slide, including the bio, and then we'll
Dr. Lai, I'm just putting it on the screen if you want.
Oh, it's there. Okay, sure. Thank you. Well, thanks, Dr. Ayman. I would like to thank Dr. Muhammad for moderating the first half, and hopefully I'll do as good as he have done. Well done moderation. It gives me a great pleasure to welcome the panelists in this second half, as well as welcome again our audience. Our first talk will be by Mr. Stein Lundby. Stein holds a bachelor degree in computer science and master degree in communication system from APFL, as well as a master degree in electrical engineering from Duke University, also an advanced degree in wireless technology from Eurocom, in addition to a bunch of accreditations and strategy from Harvard's Business School. His record is impressive, includes working in Qualcomm since 1997, holding over 100 patented inventions in mobile and wireless communications, and which makes him one of the Qualcomm's leading technologists and inventors. He had been leading Qualcomm corporate technology strategy functions on advising Qualcomm's execs on identifying disruptive technologies, shifts, and develop strategies and business cases and to drive their implementations. His talk is entitled "How PC and Mobile Are Converging to Transfer Industries." So we're all excited to hear from Stein. Welcome to this forum. The mic is yours.
Thank you very much. Give me a second while I get started. So Dr. Mohammed asked, what's the future? So I will give you the answer. Or at least one answer. Today I'll talk to you a little bit about where opportunities, and I'll tell you about my motivation here. Is very often I've got either some students or some startups or some executives of large companies or some department heads and universities who will ask me, well, I want to work on IoT. I want to find opportunity, and where do I find that? Where is going to be the big growth areas in the next 10 to 20 years? And there are two ways to look at that. One is you start at the problem. You try and identify what are the big problems that actually exist in a particular industry in the world, and then you try and find solutions. That can work, and it's certainly a good approach. And we've seen some very nice presentations in the previous sessions about that. Another one is to focus on solutions and try and see where you can map them to problems. In this talk, I'm going to suggest actually that we look at tools. And the reason why I say tools is that if you look at trends towards tools, sometimes you can get ideas as to where technology is moving. And when there are shifts in technology and shifts in industries associated with technology, you can find opportunity. We've heard about blockchain, we've heard about AI, we've heard about cloud. Those are big shifts in technology, and with them appear some new opportunities. So I'll talk about a big shift that's happening and will happen in the 2020 and the 2030s, which should bring 20 years of new opportunity to create solutions to problems. So for that, what I'm going to do is I'm going to go back in the time machine to quite a while ago, and we'll look at history. History is sometimes a good guide to see how technology has evolved. It might seem a little bit antiquated to look at these mainframes, but this is how computers were in the 1960s, 1970s, and early 1980s. We had some mainframe computers, or I should say specialized computers, that were integrated solutions, and they were built with a particular purpose in mind. So from the beginning, the people developing these tools had an idea of what solutions they're going to solve. And everything was designed hand in hand, so it actually perfectly meshed that way. So the chips, the processors were designed by the one company. So for example, Digital made its own processors. The operating system software was written by Digital. A lot of the applications were by Digital. The hardware, the boxes were by Digital, the networking protocols and so on. Everything was very specialized for one purpose, and it worked very well. And then what we saw in the mid-1980s, in particular from 1985 onwards, is a growth of desktop computers. And we had a few categories of desktop computers. One, I would say, I guess two categories. One is more, they're specialized. So Wang, which was a big, if you remember them, they were specialists in word processing. They were like the premier word processing. And I remember my mother actually was learning as a secretary, was learning how to use Wang computers, which were scary, but they were the best ever in word processing. And they made desktop versions of that. Digital made their own processors with the Alpha chip, which had extremely high performance and specialized in their particular workstations. Silicon Graphics and many others. And IBM group, a small group within IBM from Florida, actually decided to do an open approach. And there they said, well, we don't really have the resources to do everything ourselves, so the support internally at the company, so we will piece together parts from various companies. And that's where they got the processor from Intel and the operating system from Microsoft and so on and so forth. And that also led to a growth in the types of computers from the PC. So from the PC, first we had a lot of clones, because it was an open architecture, so it allowed people to start developing copies essentially of the PC. But then eventually over time, they started making new types of devices, laptops, and these even Apple iMacs are PC based. You may think of them as completely different, but actually nowadays they slowly converge to using the same hard drives, the same keyboard interfaces, the same USB interface, the same Bluetooth, the same all the internals, even the software and the chip came from the PC. And you see there the power of when a particular architecture starts opening up, it opens up a lot of possibilities to create new types of devices. This growth went beyond there and went also in the component supply. So of course, we've heard about Microsoft. This is their old logo. We've heard about Dell, NEC. Then we had some new types of companies bringing in new chips, such as, I don't have it depicted here, such as NVIDIA, who determined that actually it would be interesting to add a graphical processor unit. And then some people started developing software on top of it, such as Oracle. And at first you can say, well, they're just doing a database. How much money can you really make out of making a thing that just holds, a piece of software that holds data in it? Well, when the system is open, it creates tremendous opportunity. And Oracle started as a very, very niche product, making a database. How exciting can that be? And what are the growth prospects? To be able to grow it in new and unexpected ways and made this multi-billion-dollar corporation. Same thing with Cisco and 3Com. And I'm friends with the founder of 3Com. And he tells the story about how originally all they were making is just an interface for Ethernet, or Cisco similarly. It's just the cable that comes in the back so you can connect it to another computer. How exciting can that be? But once again, in an open system where imagination is your limit and everybody works together in a type of network effect, the growth can be tremendous. And these companies started growing further and further the ecosystem. So what started as a point solution, just one computer built by one company, grew to become larger and larger and embraced by more and more people and create more and more capabilities. And the capabilities grew beyond just the computer, because then the PC platform started being used for new types of uses in new industries. No, not necessarily computers. ATMs, money machines, are all based on the PC architecture. Ticket machines to go and buy your subway ticket or your train or others are all based on the PC infrastructure. Cash registers at stores started to be more and more based on the PC infrastructure. And we had strange applications that no one could have foreseen, such as digital video recorders, for those of you who remember TiVo, and more and more and more and more. The hardware became a platform, and that platform, because open, allowed innovators to help each other and to come up with new ideas and to feed on each other and start devising more and more sophisticated applications. Then we even went to the extreme. Now remember, till the late 90s, there was still one segment that was not a PC. It was the web servers, the data centers, and so on. That was a last remaining place where companies such as Sun Microsystems and IBM and so on still made good money. The data center, that needed a real computer, not a PC, come on. Well, we had some innovative startups, thinkers who started saying, well, why not use PCs? And this is the first, here in this picture, this is the first Google data center computer. And what they've done is they went to the store and they bought cheap PCs, I mean, cheap relative to the normal data center computer, poor performance, poor, I should say, reliability, not performance, poor reliability, poor relative to the machines that IBM and Sun and others were designing. But they connected them in very creative ways. So they compensated for the poor reliability and started making extremely reliable systems. The hardware and the software, and that also led to the concept of micro services, Kubernetes, Dockers, and so on. And Google is actually credited for launching that microservices trend, which everybody's going towards now, which essentially in summary means you write software as tiny little nuggets, and these little nuggets of code run anywhere they need to. And if they crash, you've got a master controller that they used to call the Borg that respawns it on another piece of hardware. So now you become fault tolerant. And it worked so well, these type of fault tolerant systems, that even the military systems, I remember in the United States discussing, they used to order these very expensive hardened computers, right? Mainframe computers. And then they started having branches of people who were just buying PCs and loading Linux in them and making themselves some meshes and to the hardware essentially to make them work. And even there, they realized that actually there's value in actually using this huge ecosystem that's growing. Now in the 2010s, up to then, you still real software for like a bank or something real time or running your enterprise applications. It was still, people still weren't quite sure about the PC, but we talked about Google. What happened with Google and with Twitter and Facebook and all these other companies is, and we started having more and more serious level software. And now the quality and the scope of software that's been developed on top of the PC allows you to run real-time mission critical systems. Military defense systems operate on PCs. Hospital systems operate on PCs. The stock market operates on PCs. And now people are even operating and moving their own computing to the cloud on banks and banks of PCs from Amazon, from Microsoft Azure, Amazon Web Services, and so on and so forth. We've gone from a crappy little machine on the desktop that was unreliable and a low-end disruptor to something that's extremely reliable and has essentially spread, pretty much spread in all kinds of unexpected ways to create a platform that's just unbeatable, and a platform that's essentially made impact in all kinds of industries. So industrial factories went from their specialized SCADA systems to use IoT systems that are powered by PCs and PC software. All these type of industries, hospital systems now run PCs to manage their patients, to actually manage their alarms, and so on and so forth. And we've seen, if you look from the cloud to the edge, sorry, I'm going to move here. Here's the edge. We started at the desktop, and then it started spreading to all kinds of devices in the middle, and it also started spreading to infrastructures like services, mainframe, workstations, and slowly started to spread towards things. But the PC never quite made it well in the things space. It made it to a certain point, and I gave a few examples, but it struggled there. The PC architecture, hardware and the software architecture struggled. And what happened in this world of PC where everything's become PCized is there is a new purpose-built integrated solution that appeared, the mobile architecture. Certainly there's some companies like Microsoft who tried to make mobile phones using the PC architecture, Intel processors and Windows on top of it. It didn't work. For a while, Nokia tried that, it didn't work. What happened is that we had specialized, purpose-built chips, software, everything really worked very well together. And typically everything came from the same vendor. Very reminiscent to the mainframe in the early days. So Nokia made its own chips, its own operating system. It made the apps. You could choose between the 4 apps that actually they installed on your phone. That's it. If you don't like them, too bad for you. You can add more apps. Same thing with Ericsson. They made the processor, they made the phone, they made the software, they made everything. Same thing with Motorola, same time, and so on and so forth. And then eventually we started seeing an evolution that's somewhat similar to the PC. With the smartphone, we started seeing a democratization. Now one company specialized in making the processor and the connectivity. Another few companies specialized in making the software. Others specialized in making the display, and so on and so forth. And we had more and more vendors. And then with the App Store now, suddenly anybody could start writing software. And they started being an explosion of what you could do with a smartphone, what could be used for, and in particular, the industries it could actually impact. And we see the smartphone. Remember, we're talking about a phone, right? People originally, when they designed the phone, it was to make phone calls. That's it. Then they added text because maybe you just want to send a short little message with a few characters. The transportation industry started getting completely infected with Uber. The logistic industry with tablets connected with software that connected to the enterprise systems. The car now is starting to run software type of smartphone type of software, starting first in the Teslas, but now more and more in other people's cars. Logistic management like these scanners. But also the components, not just the smartphones, but the software and the components in the smartphone started being reused. So the whole growth of drone, there's a reason why drones just appeared in the 2000s, 2010s, right? It's not because someone just invented the drone. It's because they were able to use smartphone technology. Previous to that, you could not put gyroscopic sensors that were small enough and cheap enough to actually make drones. Gyroscopic sensors were scaled up thanks to the smartphone. And then the Roomba, the new Roombas, and the Platon devices, and the point-of-sale terminals now, which are no longer these big clunky PC-like devices, but these sleek tablet devices you see in your coffee shop. And our friend Yasser's robot here that goes around and speaks to you from Amazon, and soon the metaverse, a lot of the metaverse, and so on and so forth. So following the trend, coming back to what I was saying before, we have 2 growths, no longer only the PC from the desktop, but from the smartphone also. And the smartphone now, what's happening with this is going beyond just being a specialized device. It's opened up and it's starting to spread to more and more places. And that creates a very interesting opportunity. The opportunity from a tool perspective is in the 2020s and the 2030s, a big trend is going to be the creation and the leverage of a new platform where PC and mobile work together. Where it's best, you'll use PC and cloud and so on. Although we might see smartphone processors start entering the cloud, and we're starting to see ARM processors and others, in particular Amazon with their Graviton chip. And you will use software from the cloud, and you'll use these enterprise systems, and you will also use mobile. You'll be leveraging from those 2, you'll be leveraging the devices themselves, you'll be leveraging the software alone into different types of devices, and you'll be leveraging hardware components. And together, these will bring tremendous opportunity. And that concludes my talk. Thank you. You can read more at an article I wrote on Medium. Otherwise, I'd love to talk with you either on Twitter or email me directly. Thank you.
Thanks a lot, Stein. Very informative and as well as a nostalgic talk with all those mainframes and all mobile phones. I already have so many questions prepared, but for the sake of time, we're going to discuss these hopefully during the panel discussion. So we hope you can stay with us a bit longer. And,
absolutely.
Thanks a lot. Okay, so our next panelist is Mr. Ammar Enaya. who is the regional director and country manager at Vectra. Mr. Ammar leads Vectra's business in the Middle East and in the Mediterranean region. He holds over 25 years of experience in consultative selling of networking and security solutions. He previously held the position of regional director, the Middle East HP Enterprise, and general manager at Middle East at Aruba Networks. We're very excited to hear his talk entitled AI Threat Hunting for IoT. Mr. Ammar, the mic is yours. You're welcome.
Assalamu alaikum. Can you hear me?
Yeah, we can hear you, yes.
Fantastic. So I think some part of my bio is missed, but anyway, I'm a KFUPM graduate, 1991, first honor degree, alhamdulillah, computer engineering. And I've done 4 startups from this part of Saudi Arabia, Dammam. So I started 4 companies. They're all American-based. 3 of them are California-based. And the last one is Vectra. So I'm glad to be again talking to my colleagues and my visitors in KFUPM here. Good. So let's talk about AI and how it can help in securing the OT and IoT environment here. For those of you who don't know Vectra is an AI platform, and it's headquartered in San Jose, California. Regional headquarters in Dammam, Saudi Arabia. It's a Saudi PIF investment, so it has a green blood in it. Good. Right. So IT, OT, IoT, where do they sit in the network? IoT and IT, they are in the blue side here of my screen. OT is in the green side of my screen. They're not about oil and water. They're very much converged, and there are highways between all 3. And we have seen recently ransomware attacks and other deliberate attack. They try to find the least resistant, machine to attack the network. So if they can attack through an OT, they'll do it. If they can attack through an IoT, they'll do it. If they attack through an IT device, even if it's just a small computer that the secretary is using to order pizza, they will attack it. And usually it is the job of the antivirus and the firewall to stop the attack. But we all know a deliberate attacker or an insider attacker will reach. That's a fact. And after he or she reaches to the network, they will use whatever media, mainly the network itself, to go laterally until they reach a key asset, then the damage will happen. That is why never underestimate any device in network. Don't think of it like this is just an IoT device or this is just an air-gapped OT device. A hacker will find a way to reach the least resistant. And once he is in the least resistant device, he will use the network to go to the key asset. These are some of the examples that are heavily using OT. They've been attacked recently here. So you can see here like the Colonial Pipeline or the Brentage. They paid fine, by the way. They paid money, not fine. This is ransom money. They paid it. In the Ireland Health Service Executive didn't pay. So why did I put 3 examples, 2 paying, 1 not paying? Because that's the average worldwide. 2/3 of the companies that are hit by ransomware as service, they paid. Now, how much they pay, it's secret. But from my experience being in this industry, people usually negotiate. You don't pay even 10% of the money the hacker will ask you. But if you don't have good backup, you end up paying. People who don't pay, you can know from day one, they have very good, very secure backup. That's why when the ransomware hit, usually it starts with the backup. Then it goes to the main network, okay? So the more you hide your backup, the better backup you have. From it. Okay, let's continue. Now, let me go deeper on the OT network. Now, again, people think of the OT, that's a bunch of valves, bunch of workstations, machinery, stuff. They are fully air-gapped. There is no email. There is no web access there. Why do I care? You care because they have highways to the higher layer of the OT and highways to the lower layer of the OT. And those highways usually are governed by firewalls. So where's the problem? Again, a deliberate hacker or an insider hacker, the first thing he will do, he will bypass the firewall. The same thing, he bypassed the antivirus. This is the problem. So you're not fully air-gapped. Actually, I'll show you something nicer. Let's look at layer 0 till layer 5 of the OT network. In the higher 3 layers, the protocols are purely IT protocols. And the network is purely IP network. And the highways are not only between themselves, also to the data center. So think of it. If a hacker comes from the IP network, he can use the highway to come to the OT, he will reach. And if a hacker starts with the OT network, he can use the highway to the IP network. Let's go again to rule number 1. What does the hacker want? He wants to take over your key assets. He does not care about that workstation that the secretary is ordering pizza from. That's not his target. That's his patient 0. He does not care about a valve or a thermostat. What he cares about is to move from there, we call it patient 0, to a key asset where the harm is magnified so he can ask for money. Okay, so does OT network means OT protocol? No. Only in the lower layer of the OT network, you can see the OT protocols. From layer 3 and above, it's just another IP IT environment. And that's where the hackers can work. Okay, what did we learn so far here? To have an ideal and protected OT network, you need to have asset management, yes. You need to have a change and config management, yes. You need to have operational environment management, yes. But you also need to have cyber security management. There are quality products in the market that do the above 3, like Nazumi, like Clarity, like PASS. But you also need to control the cyber security, which have 2 parts. You need to have a detailed understanding of your IT and OT network, and you need to have an AI-based solution that will automate threat detection and be one step ahead of the attacker. People ask, why do we need AI? Can we do it in the normal way? Yes, you can do it the normal way, but I'll tell you what's the difference here. In the normal way, the attacker needs to be one time correct and need to be correct all the time. When you use AI, we reverse it. You all need to be correct one time to see him, and the attacker need to be all the time correct to bypass. So AI reverse the formula. How does AI and machine learning work? Again, it's a normal mathematics here. We're talking big data and correlation. Big data and analytics, like any big data project in the world here. The big data of the AI in the threat hunting platform, we call it metadata. You've all seen Mr. Facebook, he changed his name to Meta. So again, we are in the metadata. So the metadata usually is between 0.5 to 1% of the full traffic. It comes mainly from header, so we don't care if the traffic is encrypted. And a true engine will enrich it with AI information so it can be augmented by the brain. And the brain is nothing but machine learning algorithms that are built by data scientists, mimicking the majority of the multi-attack technique, giving automation of the threat hunting platform by looking at behavior. Let's go more details here. So we're talking about data scientists and security researchers working together here. The security researchers, they use fundamental attacker behavior sourced from securing the world's most sensitive assets. And the data science is a team of PhD and professors. They come mainly from chemistry, number 1, physics, number 2, mathematics, number 3. So those scientists are highly paid nowadays, and they take their master and PhD in data science. And they do the coding using behavior across supervised, unsupervised, and deep learning models. And the result is a set of algorithms that are mimicking the majority, the higher the better. In our case in Vectra, we mimic 97% of the MITRE attack framework because the techniques are definite, while the signatures are indefinite. So you go for the definite, the techniques. So we need to mimic the MITRE attack techniques as much as we can. And if you have a true AI engine, you should automate the work. In our case, we do in average 34x workload automation. That's very important. Otherwise, you cannot follow. You're always one step behind the attacker. We will ask where in the kill chain the AI work. These are the 5 kill chain steps that the AI usually work: the botnet, the command and control, the reconnaissance, the lateral, and the exfiltration. Where is the ransomware here? The ransomware is exfiltration, but instead of data smuggling, it's mostly manipulation of data, okay? Because the ransomware does not want to take any data out. He has no power. So what he does, he encrypts the data inside the network and then asks for ransom. Okay, good. So let's have this AI coverage in the OT network. The AI coverage will provide coverage for the layer 3, 4, and 5 in the OT Bordeaux model. So the command and control protocols, they will cover the traffic from the ICS OT network to the outside. Again, even if encrypted. Why? Because it follows the metadata, which is coming from header. The reconnaissance protocols, they will cover generic protocols that are agnostic and targeted. And the lateral movement protocols or algorithms, they will cover protocols that are agnostic and exploits. And with this, we provide 3 steps of the kill chain for the OT and 5 steps of the kill chain for the IoT and the IP. I will end by giving 2 examples, and these are recent examples, by the way. These are all pandemic Corona time examples. So I don't want to go before that. So I'll start first with the chemical production industry. This is one of the customers that I watched his video. There are videos, by the way, for this customer. He was talking about it. So he was hit by WannaCry, and the goal for the attacker was to take down the entire manufacturing system and demand ransom payment. Okay, so again, the attacker landed in patient 0. And from patient 0, he started moving laterally, and there's a security gap here because nobody will see him when he go laterally. He's very slow in the motion, and he's using legitimate traffic. However, with an AI tool that the customer has, like our tool, the SOC team were able to see the attack in real time before the encryption happened. This is the important point, because after the encryption happened, it's useless. And the head of security operations, head of SOC, he said that even though the attacker managed to bypass the antivirus, the ADR, the ADR didn't see it. The AI in the R was the only part that saw it, even though it's security gap, and exposed it. This is another major attack. Again, it's all taped on video. We can share videos later. This is a pharmaceutical customer. It was trying to make a vaccine for the corona, and it was hit again by an attacker using Maze ransomware malware. And the attacker have the same goal. He wants to take down the entire manufacturing system and demand ransom payment. And here, the only way, because this attacker was coming from North Korea, he was very smart. Okay, and the only way we saw him is from the map. The AI managed to build a map showing everywhere what is normal, what is abnormal, and then from these anomalies, it was filtering, looking for threat act behavior, and from the threat act behavior, it was filtering, looking for multiple trends to the attack till the attacker was shown before he spread further. So the attack spread it at the beginning, to be honest. It's like cancer, okay? And because he was very smart, he wasn't easy to be shown. But the AI, only the AI, it helped by automating the threat hunting within reasonable time. We're talking hours here from the attack, not like seconds. The attacker was exposed and was stopped. So again, this is just my quick presentation. I hope it didn't take much time here. If anybody have a question, I'm happy to answer. Luay, to you.
Thanks a lot, Ammar. Very, very nice presentation. It has, in fact, shed some light on something that is definitely need to be solved before everyone adopts IoT. So security is definitely a great topic to discuss. We definitely are going to discuss it in the panel discussion. So we'll keep the questions for later. So thanks again. And we're always proud of our graduates, and that definitely they always shine. And we have, in fact, another graduate of ours, and that's Mr. Mohammad Al-Jallad, who also got his Bachelor from Computer Engineering at KFUPM with the first honor. Muhammad is a member of of Jordan's Engineers Association and Saudi Council of Engineers. And Muhammad's also the CTO of HP Enterprise in UK, Ireland, Middle East, and Africa. He has a broad industry knowledge and experience in mega trends like application transformation, data analytics, artificial intelligence, Internet of Things, with several industrial use cases. So we're excited to hear from Muhammad. Welcome aboard. The mic is yours.
Thank you, Dr. Ulai, and assalamu alaikum, everyone. Good evening. Let me start by sharing my screen. First of all, thank you for hosting me. It's always a pleasure to be in this forum with this great university. Could you please confirm that you can see the larger screen?
Yes,
we can. Okay, perfect. So in this quick session, I'm going to just walk you through how do we really accelerate digital transformation from all the way from edge to cloud. In the same context that all the distinguished speakers have covered earlier in today's sessions. And I'll show you how we see this from HPE perspective along with some of the trends. To start with, as you might all know, we all live in what we call a hyper-connected world where a billion of connected people, devices, and things are generating massive amount of data. And this is all leading us to have intelligence and security built everywhere. And the possibility for us to turn this intelligence and data into value, like new services, new product, more efficient operation, as we saw in the previous examples, is what's driving us to have a more connected and intelligent world, if you will. But there is an unfortunate reality that nobody is talking about. And despite the investment in digital transformation, many organizations or many companies are falling behind. We have probably $270 billion have been invested in clouds. Digital has tripled, digital investment has tripled, but yet many organizations are falling behind in this journey. And more than 70% of them, according to some statistics, are still underperforming. And the problem we are seeing in the industry today is that there is a transformation divide that is also widening. And the winners sprinted ahead, but 2/3 of the CEOs are still feeling that they are falling behind. And those winners, they are seeing or witnessing or getting double the growth, with the profitable industries in the market today being fintechs, pharmaceutical, media, or medtech. And those companies has managed really to increase their economic company values by more than $300 billion, whereas the quintile performers or the bottom quintile performance, they lost $300 billion in their market capital values. And that's a big challenge. But all the winners agreed that data is the life force essentials that is helping them to create the next gen operating and business models for their companies. However, getting value out of data is not an easy task. And many organizations, they face a lot of challenges. They jump into, let's say, AI initiatives and analytics initiatives, but I'm gonna name 3 different challenges that they face. A, how can they fast forward their multi-generational IT landscape? The second challenge, how do we really put all this petabyte of data to work and get insights out of it? And the third one, which is very important, is how do we increase our freedom to be able to run our workload everywhere, edge, cloud, or across multi-clouds? And these are different challenges that many organizations are facing. There are definitely solutions, and digital transformation is a journey. But I'm going to show you next, how do we see this as a corporate, as Hewlett-Packard Enterprise, which goes back in its root to HPE, or HP, sorry, Hewlett-Packard, which was the birthplace of the Silicon Valley. So we as a company, we have a purpose, which is, and I heard this statement, I'm happy to hear it in the previous sessions. Our purpose is to advance the way people live and work. And we are achieving this using technology as an enabler to help us engineer experiences that unlocks the full potential for our customers, regardless in which industries they operate in. That could be oil and gas, could be healthcare, agricultural, retail, or even healthcare or any other domains. So that's the whole purpose of the company, is to use the technology to engineer some experiences and provide some use cases that enhances the work and life scenarios. And all our strategy in HPE is at the nexus of those three mega trends, or what we see them as mega trends. You heard earlier the thing called the edge, which is in our definition, anything outside data center or cloud. And that is becoming a very hot topic. And I think that's the future, because when we look at the edge, that's where 60 to 70% of the data will be generated and processed without touching any data center or cloud. And 85% of this data is unstructured or expected to be unstructured, with 30% of this data is expected to have real-time processing, which is processing that is happening on the edge. I heard in the first session the example of autonomous car. That's a perfect example of how data need to be processed at the edge. Now, that's an area or a mega trend of a play. The second thing is the cloud. And our definition of the cloud is not really a destination where you need to go to or bring your workload to, but rather is to bring the cloud experience, which is the cloud speed and agility, to wherever your workload is residing. Workload could be residing at the edge, could be residing in private data center for various reasons, security, data sovereignty, compliance, or it could be also across multiple public clouds. And the reality is going to be hybrid, where every organization workload is going to be spread across all of these. And there's a big challenge here. Despite the investment in public cloud, we're seeing that 70% of the applications are still on-prem, which means they require a lot of modernizations, re-architecting, re-platforming, or even sometimes to bring the cloud experience to this application within private data centers. The third main pillar, which is, I think, the critical asset of the future, which we call it the currency of the future or the oil of the future, is data. I mean, every organization is to be more competitive, to provide better services, for governments to deliver informed decisions. And we heard those examples at the beginning from distinguished guests. They need to use data to make informed policies, to make better products, better services, and unlock inside and give better capabilities for their customers. But dealing with data is also a challenge and requires a lot of experience as well as the proper tools. And we also see increasing adoption from organizations to go into what we call consuming IT as a service. That's being in public cloud or across different sites, edges or clouds, or even private data centers. So what we see is that customers must bridge the past, present, and the future. So if you look at this picture, everybody or every organization is used to have their own data centers, centralized, consolidated, having the proper TCOs and let's say optimizations. But then we saw this shift toward multi-clouds where they have a mixed workload between a private and public. But we see them really moving to what's called edge to cloud, where they have multiple distributed sites, generating data, processing data at the edge, and at the same time communicating with the cloud where they need to do further processings if needed, and do all this to generate new experiences and new revenue streams. But they need to do this while still harnessing the power of data. And that's because they need to really build their next operating model or next business model based on data to deliver richer experiences, to cut through complexities, unlock insights, and even to bring new capabilities for the future, being more competitive or delivering extreme services to citizens if that's something that runs in a government sectors. And that's what we did as Hewlett Packard Enterprise, which is the enterprise arm of HP, is really to make the big bets around the mega trends and help our customers in powering their data first modernization movement. And that's how we structured ourselves, and we call ourselves the edge to cloud company. And I heard many questions in the beginning about what a successful digital transformation would be. And in our belief, digital transformation in its simplest form is to gain speed and agility so that people focus more into what's important, which is application and data, and leave the tedious task for the system to do it. But digital transformation to succeed, we see it covering really three different main pillars. One is the technology, which is bringing seamless technology that allow organizations to free resources and allow them to look into what's more important, like delivering use cases, looking into data and programming or coding applications that suits their business and their customers. But that's only one factor and only one factor. The toughest part or the hardest part of any digital transformation is really people. And according to McKinsey, 70% of the projects or transformation projects fail because of people. That is being employee resisting the change or management who are unable really to cope with the change. And this is a very important part. And I heard many speakers in the beginning talking about the change management and the process changes that need to be really going hand in hand in any digital transformation journey for it to succeed. The third pillar that we see it important for any successful digital transformation is economics. And that's one of the most underappreciated factor in any digital transformation journey. Having the right economic model for transformation with the life cycle, with the asset life cycle management is very important to the success of any transformation, because these are new projects and they require really the proper investment economics to be accompanied with them. And when you look at our offerings as a vendor to the market, we really cover those three aspects, and we structured our portfolios or services or solutions, if you will, or innovations around those three: edge, cloud, and data. So at the edge, we are helping organizations to really shift from that centralized approach where they have one data centers to the future reality where they're going to have distributed cloud, distributed edge sites, where they can really use the connectivity, collect data, protect it, crunch it, and send it again if needed to the cloud to redefine experiences or optimize operations or to impose a new, what we call intelligent edge. The second thing is about really creating the cloud experience. And that's really helping the customers to create the cloud strategy, tackle the security aspects, modernize the applications, moving them to the cloud, whether that's being edge, private data centers, or public, and then innovating there, as well as the ability to run the cloud. Because once your workload are distributed across multiple clouds, you need to be sure all the time that you have the proper cost management, as well as the security compliance for all these applications which are running in a distributed manner. And then the third thing is about data. And if I'm not mistaken, we have the industry's richest portfolio when it comes to high performance computing, as well as data analytics tools. HPE in the past acquired Silicon Graphics, acquired the other high performance computing company, Cray, recently as well. And we had our own HPC portfolios, and we blended all those together. And you will see in the next slides how advanced we are. And we have more than 30% of the top 500 high performance computing systems in the world. And that's all in our attempt to build what we call edge-centric, cloud-enabled, and data-driven organizations. And to share some use cases around the edge, and I know that the guests touched some of these, but edge could be anything, could be a farm, could be a factory, could be a stadium, could be a telco, or could be an autonomous car. And these are some of the use cases that we have implemented for some customers, all the way from condition monitoring, predictive maintenance, to prescriptive maintenance, to 5G in a box, which is a complete 5G network for some organizations. Also to support autonomous drivings, level 3, level 4, smart drilling. I mean, these are just sample use cases that I picked in this for the purpose of this presentation, but really the opportunity is ubiquitous, and you can think of anything that runs on the edge, and you can really digitize it, create intelligence around it, and deliver new services and opportunities. And when it comes to the cloud, we have what we call in HPE the edge to cloud platform, which is basically aiming to deliver what we call a unified cloud experience across the edge, multiple clouds, and private clouds and public clouds. And that's by giving single self-service interface, API driven, which allows us to deliver really workloads for different use cases. Say, for example, analytics as a service, or BDI as a service, or SAP HANA, or ERP as a service, or database as a service, or even machine learning as a service. And at the same time, allowing the customers or organizations to tap from that interface into different public clouds and keep correlating the consumptions and the security compliance across all the workloads that runs across these distributed clouds. And that's our platform that we bring to on-prem. And we are also charging the customers on a consumption basis if they want to bring those workloads within the data centers behind their firewalls. That's also something that we can bring to extend the capabilities all the way from edge to cloud. And the last thing that I wanted to touch before I show you a few examples is what is an area that we're playing in, which we call the exascale era, which is the future, or what we call the age of insight, which is all about the fusion of AI, high performance computing, analytics, simulation, and modeling under one mission critical system or a machine that does it all. And these machines are capable of transacting more than 1 exaflop transactions per second. And these are not really future, but really a reality. And you will see in the next few slides that we're delivering some of these systems to early customers like the US Department of Defense. But these are going to be the norm because of the amount of data that will be generated and the requirement when it comes to simulations, analytics, AI, processing. Think about genome, think about drilling, think about security, defense. These requires really huge amount of transactions. And this is what we call the age of insight, or the exascale era. And we have even dedicated a day in the month, which is 18th of October, which is 10 to the power 18th, to be the exascale era day. And now I would like to share with you just a few examples for some of the use cases that we implemented across different industries. Some of them are at the edge, some of them are within the data centers. But we did, for example, you see on the far left here that we did a few years ago what we call the refinery of the future, which is digitizing a complete refinery called Texmark in the US by digitizing their pumps, pipes, processes, and utilities, creating a connected worker, ensuring worker safeties, implementing location wayfinding services within the refinery. And we managed really to optimize their planned maintenance time by 50%. That's a tremendous cost saving within this refinery. And that's a good example for a customer or real case, which is implemented in the oil and gas domain. The second thing where we applied AI and intelligence is with Seagate, which is in really analyzing more than 15 millions of images for their production line and helping them to detect insights that the operator can't detect by their eyes. And we help them really to detect malfunctions on the production line and adjust it before it goes to the next stage. And we help them really to achieve more than 300% ROI in their manufacturing facilities. And that's a public case, and that's why I'm sharing it with you. We're also working with multiple autonomous driving vendors. One of them is the Zenseact, or the company which is behind Volvo autonomous driving solutions. Beside that, we also work with Mercedes-Benz, Volvo, Fiat, BMW, and Daimler to help them in their autonomous driving journey by applying our solution analytics capabilities to help them create the data factory and analyze data at the edge as well as at the data centers. That example that you see is for Zenseact, which is supporting Volvo to create their next generation softwares. And if you think about the autonomous car, every car generates multiple gigabytes per minute. And that's a tremendous amount of data that you can never, ever bring back to a data center or a cloud. But sometimes you need to process it next to the edge with low latency. And you could just multiply that when you think about the 5G or potentially 6G, where you have those edge connectivity around the world, and the cars can really do swarm learning and just teach each other or tell each other about any potential problem. And that's the future. These vendors are working on them. We're supporting them. We're working closely with the major manufacturers to make this a reality. And that's all leveraging technology. The last thing that you see on the right side in these examples is about creating intelligent venues as a service. And the venue could be anything, but I picked here the stadium. And we created multiple stadiums. That stadium that you see here is the Tottenham one, where it's all about using the feeds that come from cameras and sensors to create what we call intelligent experience for the fans, where we give them location wayfinding, we give them AR, VR realities. They can detect or choose their seats before they arrive to the stadium. They can have smart parking, smart ticketing. They can be treated as special customers. they can order foods to their seats, or they can be alerted or told about the least queuing facility. For example, you want to go to the restroom and you have 2 locations within the stadium. The solution or the app would tell you that you can go to that place because it has less queuing time, and it can offer you services interactively, all leveraging the analytics and the capabilities in the stadium. But it doesn't stop there. It also helped the facility managers to better manage the space. For example, if the fans are really gathering at a certain location, in the next game, they can be really rearranging the staff to go to those popular areas within the stadiums. We have implemented 6 to 7 stadiums of that shape across the world. I had the pleasure to visit one pre-COVID situation, but that solution can also apply to different use cases, and not necessarily sport. It could apply to school, university, it could apply to factories, etc. The other example I wanted to shed light on is the exascale era, and I mentioned we are playing in this domain. And these are the first 3 systems that we announced earlier this year, and we will be delivering those really to the US Department of Defense. And those are really transacting more than 1 exaflop transaction per second. That's huge. That's like the whole population working 24/7 for 4 years all together to deliver a processing. This supercomputer can do it in 1 second. And that's what we call the exascale era. It's the age of insight. It's required to deliver many use cases, all the way from genome to processings, to drilling, to defense, to weaponizations, to any type of intelligence. But it doesn't only deliver HPC. It's the mix of HPC, AI, simulation, modeling, all under one large systems, what we call it exascale era. And also, you might heard that we delivered to Saudi Aramco earlier this year what we call the MAM7 supercomputer, which is doing around 55 petaflops transaction per second. And that's all to do some breakthroughs in analytics and simulations. And it's, I think, ranked as the number 10 when it was announced, but now it's ranked as number 11 on the top 500 list across the whole world in the ranking of HPC. And the last example that we have on the right is you can think of edge not only on Earth, by the way, but you can think of it in space. And that supercomputer that you see on the right side is the 2nd generation of spaceborne supercomputer. We called it spaceborne because 2 of these today run in the International Space Station, crunching data at the edge and applying intelligence and helping astronauts in many insights, because we can't really wait for the data to come from space to Earth and go back, because that takes time. And that's the 2nd generation of the supercomputer. We sent one 2 years ago to space, stayed around the space, and it's water cooled. And these are custom designed systems to operate in ruggedized and tough conditions, as you can imagine. And last but not least, and that's the last slide, is we can't look into all these innovations and technologies and practices without remembering sustainability. I mean, that's a very important part, and I think you all follow the news, you all follow the conferences around the world. Sustainability and is becoming an integral part of any design, and it's becoming an important factor in every company's innovation, and that's something we take care of. And we are, by the way, having the largest refurbishment facility around the world, where we find homes for 89% of any equipments that we receive, and we recycle 97% of the remaining into raw materials. And our goal is really to achieve 100%. So that's a very, very hot topic that I can advise you to take care of. And that brings me actually to my last slide. Back to you, Dr. Loy.
Yeah, well, thanks a lot, Mohammed. Very interesting use cases. In fact, you guys have loaded me with so many questions that I'm going to hopefully throw back at you at the discussion time, which is going to start now. So I would like to thank you all for bringing a very interesting perspective on IoT. In fact, I see these as complementing each other, looking at IoT from a system and computing point of view, to security, to all the way applications with an eye on the system level and business perspective of IoT. So if you allow me, I would like to start by a question. And of course, everyone can pitch in and answer the questions. But since Stein has started his talk first, maybe a question that comes to mind is, you have talked about PCs and as an analogy of how PCs became a mainstream for high performance computing, which is the case currently in data centers. Now, one difference between what happened in PCs and IoT that one can, or embedded systems in particular, that one can spot is we managed to kind of converge on few number of platforms which have helped a lot in this advancement. In IoT, there seems to be a huge number of selection, and in fact the list keeps growing. So do you see these systems coming together and converging to something that is more handleable compared to just having all this kind of different systems to work with?
So yes, in some sense, there's already been some convergence in the number of protocols. If you look 10 years ago, the number of protocols for communication in IoT was much, much greater. Now there's started to be already a convergence and a reduction in the number of protocols. Certainly wireless protocols also on top of that have reduced and focused on Wi-Fi, Bluetooth, and cellular 5G. So we have a convergence there too. Where there are a lot of platforms, and reportedly 2,000 platforms, are the IoT platforms. And that's because anybody or almost anybody can make an IoT platform and start offering it. And people thought that that was actually the value, to start creating your own platform and try and get everybody on it. So GE with their Predix platform, IBM had a platform, but we had a ton of also smaller startups making their own platforms. But that comes from the fact that it's fairly easy to make, and it's not really the critical element of IoT. So I think we're going to see convergence from that perspective. And if there are some proprietary platforms, they'll start communicating with each other. But certainly we've already seen convergence in terms of the products, the technologies, the hardware and the software.
Yeah, well, thanks. Ammar, would you like to shed some light on this?
So my experience is mostly in the market. So again, I thank Muhammad and Stein on their view of the technology. But my vision is mostly coming from the market about the cybersecurity. And as I told you, we look from the market to the cybersecurity element as one element. And we all believe that attackers can use the converged network, I would say, to reach from one target to another target. And that's a very major risk in the industry. And you've all have seen during the digital transformation that happened also here, more and more of the services are becoming, as also Muhammad mentioned, going from the on-prem to the edge to the cloud. The both users are remote and services are also now remote. So again, I don't want to scare everybody, but the risk is every day getting bigger. And again, I highly recommend that everybody looks at cybersecurity at a very, say, sharp eye.
Since we mentioned security, how do you evaluate the current security? Like, where do we stand in IoT security? How much, what is left to make IoT kind of, secure to a level that people...
So security is threefold. You have the prevention, you have the detection, and you have the forensic. I'm sure you all know that. And to secure the IoT, you need to prevent the hackers from reaching it. That's the first point. How much chipset the IoT devices can have? Very limited. So all the smart softwares in the world that are securing us, unfortunately, they go into the higher computers again. So you both here at Qualcomm and HPE covering, all the way from the legacy to the advanced systems. the advanced the machine is, like a computer or a high-end device, yes, the more we can secure it, I must say that. The lower the device is, when you go to OT or IoT, are the hard to secure it. So what do? You need to move to the second level, which is the detection. And with the detection, you assume anything can be hacked, okay? And once you're hacked, the hacker will move, and then you have to see him. And once you see him, the earlier you see him, the faster you stop the damage. Number 3 is forensic, and that's very important. You have to record everything. And why do we need forensic? Because we need to know what happened, when it happened, and how to learn from it. Okay, so again, I don't want to make it too much theory. This is very much practice here. You know, if you cannot protect your IoT or your OT, don't panic. It's okay. Go to immediately to level number 2.
You're not alone.
Yeah, detect. You're not alone. You're right, by the way. Come on, everybody was hacked. You know, if you look at the names that are hacked, they're like super, companies. Okay. Yeah. So go to level number 2, which is detect, and do an AI-based detection. And why AI? Because AI it automates. You know, the entire session here is about IoT. IoT means industry. Industry means automation. So you all know automation. Okay. So automate by using AI. I'm just trying to make it as simple as that. And if you have good eye, if you have good visibility, then you're not alone. You can see the attacker. You can stop him before he does the damage. That's the word. That's the message.
Thank you. Thanks. Very worthy note. Well, Mohammed, would you like to comment on any of the 2 questions? Maybe I'll just throw one question, and then you can entertain the mix if that's possible. Especially now in your discussion of HP's vision and also mission, it seems many of the systems you have discussed, and that's a challenge I would like you to maybe tackle, is they seem to be closed systems. Like HP seem to have, everything. Now, I believe, at least from history, we learned that, we need to open up those systems. We need to work together. Different companies have to be working, collaboratively in a way to build IoT. But again, because of the heterogeneity of IoT, that there are a lot of challenges. So where do you see this aspect? Like, are companies willing to open up and work together, or they will be building their silos and kind of hide behind their own cloud castles, if I can say?
And thank you very much for this question. And I might have not delivered the message right, but just to bring to your attention that we believe that the world should be open, right? And that's the main criteria. And all these solutions that I presented, they're interoperable and they work with any, let's say, solution in the market. And these are not necessarily HPE solutions, but really a consortium of technologies that are blended together. But you're bringing a very important point. And if you noticed during my conversation and the presentation, it's all about giving the organization the choice. Choice is an important fact. Choice means the systems must be interoperable. We passed the ages of the mainframes, of the locked systems, the vendor lock. This is not going to survive. And I think Stein shed some light about the history in his presentation. So the world, we believe that every organization has the right to place the workload where it makes sense for them and not for us, right? We are vendors at the end, right? But it's very important that we should be trusted advisor, and they should have the luxury or the freedom to place their workload across edge sites, across different clouds. And at the same time, they have to have this visibility. And to Ammar's, my colleague Ammar points, there is the zero trust security approach, the visibility, all these kind of capabilities are key factors to be implemented. And with a locked system, you're really losing ground. And the reason why most organizations are failing behind this is because of what we call legacy systems, which are really preventing them or prohibiting them from going to that route. So I totally agree. The world is it has to be open. It has to give choices. And the reality is, actually, according to analysts, not my statistics, like IDC/Gartner's, most of the data and application will reside at the edge, which is outside that center of cloud. And here, nobody can control the edge. Edge could be anything, could be my cup of coffee, right? At some point in time. So it has to be open. And I hope I answered you here.
Yeah, definitely. Well, thanks a lot. Well, I'll take it to somehow, again, historic and futuristic look at. We have seen, and I think Stein shed some light on this, we have seen this, revolution starting with the mainframe, then going all the way to the PCs, and then we moved back to some centralized cloud, and then we went back to the edge, and it seems to be we are going back and forth. So do you see something happening in the next maybe decade or so where we're going to have more of those waves, and how would it look if you can see it coming? Maybe Stein would like to start with.
So you're quite right. People like to talk about what's exciting, right? And so there's attention goes in one space or the other. But eventually things balance out. Like Mohammed was pointing out, you find it in equilibrium. There's certain tasks, certain applications that run better in the mainframe, in the cloud, and certain other that you've got benefit in doing in the edge. Some of them in the very far edge of the device itself, where you're actually doing the sensing integrated with maybe the camera, others like Yasser was talking about. Some of them might be in the middle edge, where you might have a point of aggregation. So yes, the attention goes from one to the other, but ultimately what makes sense is to spread and use everything together at its best advantage.
So it's kind of no solution fits all, or like you have to have all those kind of solutions, right?
That's right. I mean, think about, let's just take a very simple example. Rideshare, Uber. I don't know if you have that in Saudi Arabia, but if it's allowed, that is. But that's a system that works, part of it works on the phone itself, right? Where essentially you've got a user interface, you've got some algorithms that run in the app. Part of it runs far in the cloud, where they're managing payments, billing, and other things. And part of it runs on the edge, where they try and get an updated view of where the driver is, where the person is, and so on. So they combine all three to achieve the desired outcome.
Okay, thanks. Ammar, you had something to share?
No, I'm just agreeing with Stein. So the edge is being mobile, and the services is being centralized. This is what's happening. In Saudi Arabia, they were objecting cloud for some time. And now they're accepting some local cloud. Okay, yeah. But at the end, the whole world is going to where you make your money. If everybody makes his money somewhere, not in building, stacks and racks. That's why I need to push the IT to the cloud and focus on my core business. So the edge is getting mobilized and the services are being centralized, and cloud is the master. Yeah. That's how it was.
By the way, smart cameras is another example. Nowadays, smart cameras do processing on the camera itself to see if there's something of interest, instead of just streaming all the data up. Because it would just be, giving the resolution of nowadays camera and the number of cameras or other type of sensors, it would be prohibitive. So the camera itself inside it has got a mobile architecture that there's some AI and determines what's interesting or not to report. Then typically, and within the enterprise, there might be an aggregation point where there's the processing and maybe the storage. And then there's a far cloud system that collects more of the slower processes.
And yeah, Mohammed?
Yeah, and I can't agree more, but I will shed some light. If you look at some of the trends that are happening these days, and the shift to what we call containerization, it's all about increasing and containerization in its form. It's running on a de facto standards, right? Like Kubernetes and Docker, which is all about really adding the portability to the applications, because you could be running those applications in the cloud, but you want to push them to the edge, or you want to push them to the data center or at different location, and that's the only piece that will make them portable, and it will allow you to take them back and forth depending on the use case, depending on the need, depending on the organization, right? Because you might be running, for example, let me pick an oil rig, right? And you lose the connectivity, but you can't stop the operation, right? That's a big challenging problem. And that's why you need to have intelligence, application portability. And at the end, you don't need to have any vendor lock-in system. You need to run them on just standard platforms anywhere you like. So that's something I'm seeing it increasingly being adopted. It's not a new thing. It started in the 70s. I think the early adoption happened in 2014. But now I'm seeing every single telco provider and customer looking into creating what we call container strategy, because that's going to make their application more portable, if you will.
Definitely, and that seems to be helping in gluing together all these different pieces that makes IoT. And,
yeah, and if you allow me to add one more thing,
sure.
It's also data, because the central data lake, or what we call the data lakes, they're now being renamed to what we call data fabric, which means data should exist everywhere, and you should have access to the data everywhere and crunch it where it's generated as well.
Yeah. Yeah, definitely. That's and again, these all pieces of the puzzle, they come nicely, but it's putting them together doesn't seem to be, the easiest of tasks to do. Ammar, there was a question about, you spoke about your company's strategy in securing AI, which we are all looking for you to help, because it's going to help us, recruit more students to study IoT. A question that comes to mind is, most of what you have discussed is AI that looks to be sorry, not the AI, but the security, which is based on AI. But a lot of it seems to be the, if I can call it, the old school centralized AI. Now with the trend of moving to the edge, doing security and AI at the edge, do you have anything to share on that? Like, are companies looking to, or local companies or domestic companies, are they working on that, on such solutions for the edge?
Yeah, so Stein actually started with this, when he talked about the camera. So, okay, now you asked a question earlier, how the world is going from connectivity, and we all discussed that most of the application being mobile now, mobility. And with mobility, you need somehow of a local AI on the peripheral itself or on the phone itself, so that you can save some of the work from the central station. So yes, a lot of the application nowadays are mobile applications, and those mobile applications, they have local AI. Yes, this is true. Now, from a security perspective, the more you are centralized, the better you are. Okay, because it's not fun to write policies for everybody. You need to centralize your policies. So it's from ages, people, when they talk security, they talk centralized and single command of control. Okay, and that's the fact is. So two answers to your question here. When we talk security, I need centralization as much as possible. So I have one set of rules, one set of commands. And an AI in perspective, yes, you're right. With IoT especially, and with those mobile applications that are spreading, local AI is spreading.
Well, that's an interesting perspective on AI and security. Now, something that I was hoping to see a glimpse of in one of the talks, but I wasn't, including the first panel, which is what is coming to IoT from 6G and next generation networks. Definitely 5G has it was designed from the ground up with IoT in mind, and people are expecting more to come from 6G. I know it is still too early to tell, but again, we're trying to speculate and get clues from the experts. So do you have anything to share on that front?
It's going to be amazing, but you'll have to wait for 10 years. I mean, there's work, people are doing work already in place. It's research stage. It's not quite clear exactly what it will be, because there are many options going forward. right now, people and operators, the industry is investing in 5G, has invested in 5G, and the time now is to focus on 5G and leveraging 5G. 6G will come in its time. And as you know, these Gs happen every 10 years. So as Yasser says, we might be retired by then, but maybe the next generation will work on it, but it's not yet decided what it is.
Yeah.
Maybe I can.
Yeah,
sorry.
sure.
Oh, go on.
Yeah.
Yeah, so a couple of things. So as my colleague said, 6G is in a research stage. At least I know that our company is part of this. But most of the customers that I'm seeing today, especially the ones that they're dealing with ports or large connected devices, they're leveraging a couple of things. One, the Wi-Fi 6 technology, which is also designed for such technologies or the IoT devices. And the second thing is creating what we call private 5G stack. Which is the ability to really offload or creating really high-speed network for that specific organization and try to offload, let's say, the load between the 5G and the wireless. So that's what's happening today. And I think it's running at a very, very extremely good speed that nobody is there yet except for a few customers. That was my bet. Sorry. Over to you. I think, Yasser, you wanted to add a comment.
Yeah, just maybe visionary discussion, but it has a little bit of connection to reality. So where we think things will really advance, and those are like cycles you can call 10 to 15 years. And those are the areas where the current audience is actually probably going to look for, is, in my opinion, two areas. The vehicles, smart vehicle, autonomous driving, and seamless, pretty much zero accidents. That's an area where if we look at the current automotive technology that's connected to the 5G, it's just starting now and probably going to deploy in 5 years. So the 6G would address a better experience, more secure, high dependency, and all of the use cases that got missed in the 5G up to like release 16, 17, or what's been worked on right now. So I think the smart vehicle, the fleet management, all those things will be an area of multiple innovations that will be addressed in 6G. That's one. The second one is a true blur, and me and Stein could talk for hours about this, but that's okay. A true blur between the wireless technologies. So you want to have a complete seamless, if you move from a Wi-Fi to 5G, 6G, then let's say to a different technology like Zigbee to Z-Wave, or all of these networks. It doesn't mean anything to not only the user, which probably can address in the application level, but even to the application developers. So you actually talk to an API black box and you do your innovation somewhere and you don't really care how in practicality you will go from one technology to another. And 6G would have a space where you will blur these boundaries, which is right now until today with even the most advanced Wi-Fi or other setup, you will have to have some technical understanding to put things together, to work together.
Well, that's a nice perspective to look at what is missing, probably in 5G, and I guess that's a very good, strategy to see what to expect. And I
like Yasser a lot, but I disagree with him. 5G is not missing anything; it has everything, and you should deploy it now.
Okay.
There is nothing wrong to hope for even better.
We'll stay with this, Stein, then. We'll stay with this. For the new generation, this is a cassette. This has multi-purpose. It used to be for three things in my age of the cassette, the big Walkman thing. You can listen to music with it. You can throw it at someone if you're angry at it, and you can throw it from car to car in a machine-to-machine messaging. And some people will understand that.
Well, that's pretty advanced for some people, I guess.
So, but, look, coming back to bridging this question you had also the way earlier, and then questions in the previous panel. One of the big malaise, as such say, around an IoT, right? And is essentially what's IoT for? What is it for? What is it? And if you can make an analogy to multimedia in the 90s, and Khaled, who's commenting, actually was working in multimedia in the 90s. And there was a big challenge. Everybody worked on multimedia. Everybody knew it was going to be really important, but no one really had an idea of why or how. And everybody said, we've figured out multimedia, but no one had really figured out multimedia. And in the last 10 years, we've seen multimedia really used, actually last 20 years, really used massively by online streaming and Netflix, by people taking videos, by Instagram, by Facebook. It's become just, and now by the virtual reality and augmented reality, it's become just massive. And that's a similar problem with IoT, and why you see so many standards and so many platforms, because people are taking solely a technology-driven approach, and they're saying there's something great there, there's gold, I know, but I can't figure it out. So let's gather together and have more standards, or let's develop our own platform, and everybody will come to our own platform. No, the solution is to marry finding problems, finding the tools, the technology, and then coming to solutions. It's difficult because it's not actually a point solution, just like multimedia. It's not a focused one thing, like we're trying to improve the fuel efficiency of the car, right? It's very well defined, very well scoped, and you know what the problem you're addressing here. Here, the problems are industrial, they're in the home, they're elsewhere. And for example, in all these environments, in particular industrial, you need to really, really have good domain knowledge to be able to do so, just like we saw the previous presenters. And very often, you don't have those people who've got the understanding of the tools, the understanding of the domain, and also the willingness and the leadership from the executive team to actually implement those solutions. And that's why there are a lot of failed starts with IoT, and a lot of hesitation, and a lot of people who are just spending time doing things that thinking it's not yet now. We need more standards. We need more platforms. We need new technology. The path forward is actually marrying the three and applying it.
Yeah. Yeah, well, definitely there are, in addition to the technical challenges, there are other challenges, as you stated, especially, and well, human is a big factor in that, definitely. And now maybe time is almost, we're running out of time, and I would like to apologize for Yasser. I did not realize he would, he's still here. I would like to thank him for sticking around. I think his perspective will always add definitely value to our discussion. But since time is almost over, I would like to end with maybe the following is, if I would ask you, what is the biggest challenge you see currently in the way of adopting IoT, like for IoT to move forward? What is the biggest challenge that you wish, or you think if it can be solved today, things will change dramatically? Maybe I'll start with Mohammed, if you would like to comment here.
Yeah, I think I'm gonna share this answer based on what I'm seeing, right? And if I'm honest, I think it's not the connectivity, because that's something we can achieve. Connectivity is something that is hot, but I think we need more scientists, and I don't mean here programmers, but really data scientists. That's my answer.
Well, okay. We were hoping you would bring more students to us. Now they're moving to ICS because of.
Thank you.
Well, thanks for helping us. Ammar, would you like to comment?
I was saying the same thing exactly, but he went ahead of me. That's what we need. And again, I agree with Stein. Connectivity is there. We have enough connectivity, and we need some intelligence.
Okay. And Stein?
I think we're at a golden time, and we're at a critical time where it's starting to happen. It's the combination of the tools, meaning the technology and the know-how, whether it be data science or hardware or software. It's and assets, of course, meaning already have these platforms available. It's the combination of the domain expertise, so you can identify the problems. And then it's the combination of the desire and the drive to implement solutions. And that's happening right now. And I think we're in a very, very exciting time. We'll see tremendous growth in the next 20 years.
I like that remark because I'm sure it is going to bring more students to us now. So I'll end with the answer since you are still around. Would you like to share your thoughts on this particular aspect?
This one, yes, and I wouldn't stay away from, I think great minds think alike, and I actually wrote down human factor, and the first time you're asking the question, one of the biggest challenge right now in using the technology. Let's think about building. We have the pipes, we have the some of the major technology that solve some of the problems. We don't have builders to actually put this together. It's because we don't have enough engineers in the world. And people think, oh, we can hire all we can from different regions, which they have a lot of engineers. The problem is those engineers are new grads in certain areas that are not capable to actually address the technologies that's needed. So by the King Fahd Petroleum University specifically addressing this huge vertical, and having the right curriculum for it, and bringing the industry to actually advise them on it, will help have graduates who are ready to challenge the world with their ideas and inventions. It is, again, double down on human factors. I personally have a huge problem filling some of the positions because of the lack of qualified engineers, new grads qualified engineers, because you don't want to have somebody who did all of their life doing in the study life, doing something that is really far. Yes, a good good student that's graduate in engineering is applicable, but to address this area, you need to have somebody who's interested in it, because it's too specific and we don't have a lot of time to ramp up. I mean, the technology is very fast, processors are very fast, memory technology is great, we have a lot of memory, and we have a pipeline that holds NASA stuff in 5G and others. Now you need to start to build stuff that go through it.
Well, in fact, in a related note, I think we're doing pretty well because we're working. We're very optimistic to be working with young students who are hopefully are going to attain this knowledge and skills, and you will not need to change their minds. So they will come to you ready, hopefully, to make the change happen. I would like to really thank you all for the insightful discussions and talks. It has been, a pleasure moderating the session. Learned a lot from your experience, and I would like to also thank you for staying. This was an endurance race for sure. It was a very long, forum. I would like to also thank our audience who, stuck with us for a very long forum. Thanks again. Thanks for accepting our invites, and hope to see you again in a more fruitful discussion and such exciting events. It's over to you, Dr. Ayman.
I really would like to thank you, to thank all our distinguished speakers for very inspiring and very interesting talks and discussions that we had. I'm sure that all our students are going to come out of this forum with very inspiring thoughts and motivated basically to work hard and try to get the skills needed for the industry. In fact, actually, as you heard the president saying, the university has taken last year an action where all our programs, we have injected a course on data science and a course on artificial intelligence. So all students in all majors must take these courses because we know that the industry needs these skills and so on. In addition, we opened the concentrations where students in the last year specialized, like some of them specialized, for example, in IoT, some of them on data science, some of them on cybersecurity, artificial intelligence, cloud computing. Actually, there are like over 30 different concentrations because we realized that we need to graduate specialized students. They have strong foundation, but also they focus on certain areas. We are also offering master programs, like professional master programs. For example, in the department, we are offering a professional master on Internet of Things and embedded systems, covering all these areas that you talked about, like IoT security, industrial Internet of Things, big data analytics to better prepare our students to the market like cloud and edge computing. So we thank you really for, I think, this successful forum, and looking forward to collaborate with you. And we thank you all for your time. We thank our moderators, Dr. Lai and Dr. Filimban, for doing a great job. And we thank the audience for joining our forum today. And we hope that we meet in other successful forums. Thank you.
Thank you.
Thank you very much.
Thank you so much, everyone.
Hopefully the next one will be physical.
Inshallah.
Inshallah.
Thank you.
Have a good one, everyone. Thank you.
Thank you.